Dr. H.S. Patel. Dr. H.S. Patel.
Director.
Yes. Hello, hello.
Dr. H.S. Patel.
Yes, Tushar sir. Hello, Tushar sir. I am audible.
Yes, yes, you are more audible.
Okay, okay. Hello, Tushar sir.
Yeah, please.
Some disturbance from your side.
Yeah, I have just switched off the fan. That's why
Okay,
some heating problem is there.
okay, okay.
Madam Vaishali. Madam Vaishali.
हाँ सर.
Can we admit all the participants by after verification? Please.
तुषार सर.
Yes.
हाँ.
Admit the participations after verifications. Okay.
ओके ओके.
Hello, Udvasi.
Yes sir. हेलो.
હા હા. ઉર્વશી ડિસ્ટર્બન્સ આવે છે. હા, ફેન ઓન છે.
ફેન બધા બંધ છે સર.
ડિસ્ટર્બન્સ શાનો આવે છે?
Proceed.
ના ના પપ્પા.
Urvashi. Hello.
સર પેલો પાછળથી કદાચ કોઈ અવાજ આવતો હશે જનરેટરનો આવે એવો આવે છે.
atau jahat Habis betul betul terus taruh kursi. Nakal di mari. Pak Hupriya.
All the dignitaries and participants present over here. Shortly, we will start our inaugural sessions sharp at 10 o'clock. Please bear with us. During that times, I'm sharing our university song. Kindly enjoy it, please. आपकी स्क्रीन शेयर है, आपकी स्क्रीन शेयर। હિરેન આવે છે અવાજ, દેખાય છે વિડિયો? હા,
Hello.
hello,
Hello.
good
Am I
morning sir.
audible? Dr.
Yes
Tushar
sir,
Kumar, am
you are too much audible sir.
I- Okay.
We are waiting to for Dr. Honorable Deputy Director General Sunil Kumar Chaudhary sir. with the permission of chair, we shall proceed further, sir.
Yes, we can proceed. Honorable Vice Chancellor sir and Honorable DDG sir is present over here on this virtual platform. So go ahead.
Thank you, sir. Hello, everyone. Good morning. Thank you, everyone, for taking time and being over here. It's a give me immense warmth and great pleasure to grace all of presence in the beautiful morning of inaugural ceremony of the webinar. My name is Dr. Tushar Patel, co-convener, and I am the Assistant Professor Agronomy. Feel privileged to offer heartfelt welcome to all the dignitaries, invited guests, great scientists, academicians, administrations, young researchers, and students from over the world to attend the national webinar that is on sustainable agriculture through natural resource management that run for 5 days from 4 to 8 January 2001, hosted by Department of Agronomy, College of Agriculture, NAU Campus Bharuch. On this auspicious occasions, I would like to glad to introduce the dignitaries present over here. We feel honored to have with us the patron of webinar, respected Dr. Deptt Patel sir, Honorable Vice Chancellor of Navsari Agriculture University, Navsari. The next dignitary to honor us with the gracious presence of Dr. Suresh Kumar Chaudhary sir, Honorable Deputy Director General, Natural Resource Management, ICR, New Delhi, as a chief guest of the webinar. We have also witnessed the valuable presence of respected Dr. S.R. Chaudhary sir, Director of Research and Dean PG Studies, Navsari Agriculture University, patron of the webinar, respected Dr. K.G. Patel sir, Dean Faculty of Agriculture and Principal, College of Agriculture, Bharuch, Dr. Himanshu Pathak sir, Director ICR, Natural Institute of Abiotic Trace Management, Baramati, Dr. Ajit Singh Nain, Director of Research, NABARD Chairperson, GB Pan Agriculture University, Pantnagar, and many more dedicates and decorated officers from SAUs and ICR, and the research persons from abroad, Mr. Matt Newlands. Now, without further ado, I invite Dr. K.G. Patel sir, Dean Faculty of Agriculture, NAU, for formal welcome of the dignitaries and participants present over here. You are requested to give a brief introduction and overview of the webinar also, sir. Dr. K.G. Patel sir,
Okay,
the platform is yours.
Good morning, everyone. Today, at the eve of the national webinar on sustainable agriculture through natural resource management from 4 January to 8 January. So this is actually 5 days national symposium organized by the College of Agriculture, NAU Campus Bharuch. At this auspicious program of the webinar, the 5 days national symposium, we have with us Dr. Deptt Patel sir, Honorable Vice Chancellor, NAU Navsari. We have with us dignitaries like Dr. Suresh Kumar Chaudhary, DDG, ICR, New Delhi. We have with us our Director of Research, Suresh Chaudhary, and number of the dignitaries across the nation and world. So all are here welcome on behalf of NAU Navsari. So first of all, it is my immense pleasure to welcome our Honorable Vice Chancellor of NAU, Dr. Deptt Patel sir, on this project. And I also feel proud to welcome Dr. S.K. Chaudhary sir, Honorable Deputy Director General from New Delhi. And I also welcome all the university officers, scientists, participants, as well as resource persons across the country and world on this virtual platform of national webinar. Sharing of knowledge is a continuous process for development and upliftment when the whole world is facing the problem of COVID-19 under such circumstances. It is much useful to share the knowledge and ideas by online platform. So the College of Agriculture Bharuch has taken a lead to organize such webinar. But first of all, I will discuss later on, but there is a demand of Dr. S.K. Chaudhary sir that he is busy with under scheduled program. So I am shortcut this my speech, and later on I will give the detailed address. So I request Dr. S.K. Chaudhary sir to give his special guest speech. Thank you, sir.
Thank you so much, Dr. Srivastava, and good morning to each one of you. Right in the beginning, I would like to place on record my sincere best wishes for the Happy New Year 2021. And I feel and pretty sure that this year will be much better year, safe year, and prosperous year for each one of you. The worthy Vice Chancellor of Navsari Agriculture University, Dr. Deptt Patel ji, other colleagues who are present here, I find many ICR colleagues from NRM side as well as from different SMD side who are present here from different institutes of ICR, all the colleagues from Navsari Agriculture Universities, and some colleagues I'm able to see from Maharashtra as well. It is a great pleasure to be present in this gathering wherein you are just trying to cover the whole arena of natural resource management in relation to sustainable agriculture. And Navsari Agriculture University is very well known for resource management, whether it is soil resources, water resources, or climatic resources. The university has done very well in the past. Last year, in the month of February, before this lockdown was started, I think Navsari was the last university I visited. And that time, Dr. S.R. Chaudhary was there, who is now a director of research. He was present in the capacity of acting vice chancellor. And we had a very brief but very nice time together, maybe a few hours. And Navsari is one pet destination I visited since 90s continuously because my association with the AICRP on water management. And from that point of view, Navsari Agriculture University is very close to my heart. Similarly, your cotton research station and your now agriculture college in Bharuch, we too have our one establishment. You know very well that our regional station of Central Soil Salinity Research Institute works right there, shoulder to shoulder with you in Bharuch, and trying to address various dimensions of soil salinity, the poor quality waters, and sustainable agriculture in the vertisol region. Vertisol, which poses a different kind of challenges as compared to other land resources in India, unlike in IGP or coastal, or unlike in other inceptisol belt or alphisol belt. Vertisol has its own challenges. And the kind of investment required for the improvement and the kind of skill required for the management is different than other parts of the country. Dear friend, I would not be speaking at length, but very critically, I would like to define when we say that sustainability of agriculture and sustainability of natural resources, or judicious use of natural resources for sustainable agriculture, or deploying natural resources judiciously for sustainable agriculture. Now, 2-3 terms are very important. When we say sustainability, often we talk, and it became fashion to speak on sustainability nowadays. Sustainability has its own dimensions. My colleagues are here, and I have seen your program for 2-3 days, 4-5 days program for this national seminar, 4 to 8, and I saw you have covered almost our entire cross section, and deliberations will be there, and definitely the students and young scientists will be benefited immensely from these deliberations. Dear friends, when we say sustainability, it is for agriculture, it is for natural resources, or it is for whole environment. Unless we talk sustainability in environmental terms, probably we do not do justice with the word sustainability. Sustainable agriculture, maintaining the balance of all the inputs and having uniform and unified ecosystem services all across the sectors, then the system becomes sustainable. So therefore, instead of talking of agricultural sustainability, if you talk in totality, the environmental sustainability, this would be most appropriate. And there are 3 pillars of sustainability. Sustainability cannot be completed by speaking only of soil, only of water, only of climate, or only of any one resource, including the human resource. So there are 3 pillars. The first pillar of sustainability is social sustainability. Second is environmental sustainability, and third is economic sustainability. Unless all 3 are tied together, we cannot discuss sustainability in isolation. When we talk of environmental sustainability, the agricultural sustainability and use of natural resources to attain agricultural sustainability, it becomes automatically part of environmental sustainability. Why? Because these have interlinked with the social and economic sustainability. If any intervention you want to make it successful at any scale, all these three needs to be waved together, that is social, environmental, and economic. Why? Because whatever decisions we make in the name of agricultural sustainability, they are intergenerational decisions. Means decision of one generation is highly influenced by the decision of the other generation. People down the line after 50 years would be certainly affected by the decisions taken by our generations today. And after 100 years, the decisions taken by 50 years onward generation. So these are the intergenerational decisions which makes whole society and the matrix of society influenced by your decisions. And when society is involved, definitely economics is also involved. And therefore, unless anything is economically and socially sustainable, it cannot be environmentally sustainable. It may be possible, but it cannot sustain for a long time. Then the second dimension is the target. In normal agricultural production or commercial agriculture or corporate agriculture, our target is GDP, the gross domestic profit, the GDP which is contributed for the country's welfare. But in the case of sustainable decisions, the target is welfare. Welfare of the masses, welfare of the community, welfare of the society. Therefore, when we talk of sustainability or environmental sustainability or agricultural sustainability, the targets become welfare and not the GDP. Therefore, speaking in terms of GDP may affect the environmental sustainability adversely. Similarly, when we talk of sustainability and want to have sustainable agriculture, then avoid excess pollution. Earlier, we used to say avoid excess use of chemicals or inputs or whatever it is. But now we say avoid excess pollution because we have crossed all the limits and slowly inputs are reaching in the range of pollution. That means excess use of any input, be it fertilizers, be it pesticides, be it herbicides, or whatever you say, excess use of any input is leading to pollution, or that may lead in coming future to the pollution. And therefore, soil pollution has become one of the very, very important subject nowadays. Similarly, water quality and water pollution that also affect the agricultural sustainability adversely. It may have positive and negative impacts. In sodic soil regions, saline water may be a good resource, but in saline soil regions, saline water may not be a good resource. In coastal areas of Andhra Pradesh where excess nitrogen is being used, urea is used, now nitrate pollution is reaching to the groundwater and drinking water concentration of nitrogen exceeding 10 milligram per liter. So these kind of problems are coming. These are the problems of future. But unless we have solutions together, unless we have policies right today, this is going to affect adversely to the next generation. Similarly, when we talk of environmental sustainability, we talk ecosystem in totality. And therefore, our motto is to protect the health of ecosystem. When we are going to protect the health of ecosystem, then the aspects which you are deliberating in 4 or 5 days seminar, each of the aspect become very, very important because each of the aspect is directly, not indirectly, directly linked with the health of the ecosystem, not only soil and water, the whole ecosystem, entire ecology will be affected. And therefore, this kind of deliberation would certainly help us to check out a plan which will be worthy for future to to maintain the environmental sustainability. The last aspect which I would like to touch upon here is shifting to renewable resources, particularly the energy resources, renewable, where there is a possibility of renewal. So this kind of renewable resources, particularly for the energy, if you go for that, then it becomes sustainable from the environmental point of view, and it becomes environment friendly in future. The parts of western part of Gujarat, the Bhuj, also the desert part of Rajasthan, where a lot of radiation possibilities there. And there is a possibility to convert this radiation into renewable energy in agriculture. Therefore, my friends, over and non-judicious exploitation of natural resources lead to poor environmental sustainability. And it becomes the duty of each of us, whether we are working for NRM sector or non-NRM sector. Each of us, it becomes very pertinent to find out strategies, ways and means forward so that we can avoid the overexploitation of resources. And the land of Gujarat, where intensive agriculture is being practiced, very scientific and systematic agriculture is being done, in this region, everybody is very well aware. If you consider the fertilizer consumption of Gujarat and fertilizer consumption of Maharashtra, probably these two states are very, very wise states, where still the fertilizer consumption is in the range of 4:2:1. The ratio in which fertilizers are consumed is not skewed towards nitrogen as it is happening in the case of Telangana, Andhra Pradesh, Haryana, Punjab, and Western Uttar Pradesh. So this kind of wise agriculture we need to practice. The wise agriculture, in simplest language, wise agriculture is the agriculture of future. Wise agriculture only will lead to sustainability, and not only agricultural sustainability, but the whole environmental sustainability. Dear friends, I would like to stop here, and I convey my best wishes for a successful seminar, and good recommendations will emerge. Your recommendations will be liked by the government of Gujarat, government of Maharashtra, or any relevant governments. And I'm pretty sure if you discuss thoroughly and if you come up with the better work plan for each of the district of the Gujarat, definitely there will be many people to purchase your output. So with this, all the very best, and I place on record my sincere thanks for inviting me in this webinar. And once again, I convey my best wishes for the Happy New Year. Thank you so much.
Thank you so much for your word of wisdom and sharing extremely resourceful information, sir. You have insightfully sensitized the importance of sustainable agriculture and natural resource management in reference to present and future perspectives. Sir, we are always eager to hear from you, sir. It will definitely enlighten and ignite the mind of new researcher like me, sir. It also inspires researcher for taking a new and innovative research by considerations of the requirement of the future as well as present generation, sir. Thank you again, Dr. Suresh Kumar Chaudhary, sir, for your inspiring and meaningful words. Please accept our sincere thanks, sir.
Thank you very much. And I may please be excused. I'll be taking leave. Thank you so much.
Thank you, sir. Now, as you all aware that Honorable DDEG sir, NRM is too much busy with his schedules. So Dr. KG Patel sir is discontinue his welcome speech. So again, I invite Dr. KG Patel sir, Dean Faculty of Agriculture, for welcoming the participant, as well as also give some basic introduction regarding the webinars.
Thank you, Dr. Tushar, for giving me again chance for the welcome address. Actually, Dr. Chaudhary sir was very busy in his routine work, and he has to join another program. That's why he requested that first he has to finish his speech and then he get started with this. So on that considering, I am again starting my welcome speech. So thank you very much to her. Thank you. Actually, in the national webinar on sustainable agriculture through national resource management, it is very important topic at the present scenario. Because nowadays we are doing that. When the whole world is facing the problem of the COVID-19, under such circumstances, it is much useful to share the knowledge and ideas by online platform. And you know that during the COVID-19, our whole the world was suffering to starvation. At that time, our country, our honorable Prime Minister have signed the number of the much quantity of the cereals and grains to needy countries. That we can say that we are self-sufficient in the grains and production. So again, it is necessary to combat the problem that will be faced in the future. So natural resource, especially water and soil, are essential for the function and structure of the agricultural production. Number of the natural resources are there. So first of all, we have to manage the natural resources in such a way that we can enhance or we can increase our production. There are 4 pillars. First of all, that we have to protect all the natural resource components. Secondly, we have to conserve all the natural resource components, and then we have to enhance, and we have to efficiently use all the natural resources. So it can be useful to increase the production. In agriculture, it's account for roughly 70% of the total fresh water and withdrawal globally. Farming also contributes to water pollution.
Urvashi, please unmute Dr. KG Patel, sir. Now it's okay, sir. You can continue, sir.
Okay. Now, as we know that all these due to all the pollutions, our production is going to decrease and decrease. So we have to. So it is made to increase the production. As you know that in the comparison to developed countries, our production is less by 30 to 50%. So there is a lot of chance to increase our production, and increase of the productivity can help push progress towards future food security and the general well-being of producers and rural communities globally. But given the limited natural resources based on which agriculture depends, sustainable development will ultimately depend on the responsible management of the planet's natural resources. Then the purpose of this webinar is also to provide a better understanding of the concept on sustainable agriculture through natural resource management. Sir, in this webinar, totally 653 participants from 22 states of the country and from the 14 countries are going to be participants. And among these, 239 are faculty members, 289 are students, and 125 are innovative personalities and others. And in this webinar, we have covered most of all the sectors of agriculture, which are most important for sustainable agriculture through natural resource management. Totally 21 lecturers will be delivered by experts from ICR institutes and SAUs during 5 days. And we have one distinguished lecturer from Australia also. I hope after completion of this webinar, participants will get a good knowledge and information. I am heartily request to all the participants to attend all the lectures consequently next 5 days of the webinar. So again, I heartily congratulate Dr. Divesh, who is a coordinator of this seminar, Dr. Tushar, co-coordinator, Dr. Hiren, Dr. Dheeraj Kumar, and organizing team of webinar for selecting such a meaty and informative topic. It is a matter of proud that even under the COVID-19 situation, College of Agriculture Bharuch has successfully organized 9 webinars on the very realistic and useful topics. I wish a great success to this webinar. Thank you very much. Jai Hind.
Thank you, Dr. KG Patel, sir, to give a red carpet welcome to all the dignitaries and the participants assembled over here. Also, you are giving the valuable insights on the topic that is on sustainable agriculture through natural resource management, sir. Thank you again, sir. One more time, for those who are just joined, kindly accept our sincere welcome. It is a great honor for me to request the chief guest, Dr. J.P. Patel, sir, Honorable Vice Chancellor, Navsari Agriculture University, Navsari, for his blessing and remarks. We are waiting with full of ebullience to listen your motivational word on this valuable occasion, sir. The platform is yours, sir.
Very good morning to everybody. A webinar organized by the College of Agriculture, Bharuch on sustainable agriculture through natural resource management. On that occasion, we have just left our very important personality, that is Deputy Director General, Honorable Dr. S.K. Chaudhary, sir. Our University Director of Research, Dr. Sunil Chaudhary ji, Dean Faculty of Agriculture, Dr. K.G. Patel ji, Director of Extension Education of our University, Dr. Dimbadia ji, Director of Student Welfare, Dr. R.M. Nayak, Principal of Navsari and Mugai College also, faculty members, students, and all the participants across the country, as well as the globe, because this is, I can say, this is an international webinar. On behalf of the NAU, I heartily welcome to Dr. S.K. Chaudhary sir, DDG NRM, as well as all the present over here. Outside of this, I would like to extend my warm wishes for a new year. May this year brings you all with happiness, spirit, new goal, and achievement. You shall always walk on a glory of the success. Please stay safe, and stay blessed. Dear participant, as an agriculturist, our aim is to manage the natural resource sustainability for achieving food, nutritional, environmental, and livelihood security of the country. Over-exploitation beyond the resource and capability, or an imbalanced use not in harmony with the local situation, may lead to degradation of resource base, loss of biodiversity, decline in productivity, and environmental deterioration. With the shrinking per capita land, water, and prevalent increasing demographic trend is putting further enormous strain on the already overburdened resource base. This unhealthy situation has become more prominent not only in India but worldwide as well. Water is treated as a free commodity, leading to unsustainable exploitation, and therefore, in future time will come when we have to pay for the use of water in agriculture, and we may not be able to pay as much as other sectors would be able to pay. In spite of the abundant water resources in our country, there are several problems. First one is the water resources in the country are not distributed uniformly. The next, it is followed by pollution of surface, groundwater resources may not leave all our water resources potable. And then lastly, in the year with the abnormal rainfall, sometimes low, the water resources scenario may become quite serious. Looking to the soil degradation map of the India, almost 57% of the total geographical area of the country has been affected by various land degradation problems like water erosion, wind erosion, terrain deformation, and overflowing and shifting of sand, dune, etc., induced largely by human intervention. The emergence of the multi-nutrient deficiencies in soil owing to adoption of faulty nutrient management practices has also been seen on the farmers' field. Investigation highlights the significance of need-based application of nutrient instead of balanced application of NPK only for enhancing productivity, but a sustainable saving can be made through location-specific soil taste-based nutrient management. Looking to the forest in India, per capita forest availability is merely 0.07 per hectare. Deforestation has been one of the major causes of land degradation. The poor quality of forest cover has not only accelerated the problems of environmental degradation, but has also led to the deficit of fuel and fodder. Under that circumstances, the multi-purpose tree species what we call it as MPTS in agriculture field and wasteland play a significant role in augmenting the fodder, fuel, and small timber resources. Nowadays, climate change is a big issue which is unpredictable and posing threat to health, agriculture, peace and security, and the global economy. This leads to a global warming which not only causes a change in average temperature and precipitation, but also increases the frequency of floods, droughts, heat waves, and the intensity of typhoons and hurricanes following the change in temperature and precipitation patterns. Intergovernmental Panel on Climate Change (IPCC) emphasizes that it is very important for the agriculture sector to adapt to climate change. This is because even if greenhouse gas emissions decrease, global warming will still render lasting for the next year with the abnormal rainfall previously sometimes low the water resources scenario, especially as agriculture is climate dependent and susceptible to climate change. It is very urgent to prepare adaptation measures against climate change. Proper countermeasures based on scientific diagnosis and assessment of the impacts of climate change on agriculture are essential in establishing the vision and the administrative policies of the future agriculture. This will also provide valuable information for local governments in establishing mid to long term agriculture development plans and for farming households to prepare their production plan. We should develop the location specific, cost effective, eco friendly conservation and management technologies for higher use efficiency, agriculture productivity, and profitability without deteriorating natural resource base. The NRM research program have been a priorities within the perspective of different themes, namely soil inventory and characterization, integrated soil water nutrient management, watershed management, resource conservation technologies, crop diversification, integrated weed management, integrated farming system, including agroforestry, dryland farming, arid, coastal and hill agriculture, abiotic stress management, climate salient agriculture, conservation agriculture, wastewater utilization, solid waste management, and application of nanotechnology to enhance nutrient and water use efficiency. The major concern of NRM are low farm productivity and profitability, land degradation, low water productivity, soil health deterioration, and low nutrient use efficiency. Abiotic stresses including climatic abrasions and loss of tree cover and deterioration in ecosystem services. Now, it is the time to get down to earth and take urgent action on solving those issues toward a sustainable, inclusive, and resource efficient path. In this webinar, most of the aspects related to natural resource management will be covered, and the well-known speakers from ICR Institute as well as state agriculture universities will deliver the informative lectures. This webinar will be very informative for students, scientists, and faculty throughout the country. I heartily congratulate Dr. K.G. Patel, Dr. DVS, Dr. Tushar, Dr. Hire, and organizing team of webinar for selecting such a needy and informative topic. It is a matter of proud that even under the COVID-19 situation, College of Agriculture Bharuch has successfully organized 9 webinars on very realistic and useful topics. I wish a great success to this webinar. Thank you. Jai Hind.
Thank you so much, sir, for influencing message. We are charmed by your sharp fluency and highly enlightened the topic with your kind words, sir. Your words of appreciation truly mean lots for all of us, sir. Thank you once again, sir. Now, may I request Dr. D.D. Patel, sir, convener of the webinar and Professor Head, Department of Agronomy, for propose a vote of thanks.
Thank you, Dr. Tushar Patel. On this auspicious occasion of inaugural function of this webinar, here with us, Honorable Vice Chancellor of Navsari Agriculture University, Dr. Deptt Patel, sir. Honorable Deputy Director General NRM and Chief Guest of this webinar, Dr. S.K. Chaudhary, sir. Respected Director of Research of Navsari Agriculture University, Dr. S.R. Chaudhary, sir. Respected Dean, Faculty of Agriculture, NAU, Dr. K.G. Patel, sir. Respected Dr. Himanshu Pathak, sir, Director, ICR National Institute of Aquatic Stress Management, Baramati. Respected Director of Research, G.B. Pant Nagar University of Agriculture and Technology, Dr. Ajit Singh Nayan, sir, is also here with us. Respected Director of Extension Education, Dr. C.K. Tippadia, sir. Respected Principals of Annam College of Agriculture and Vagai, Dr. M. K. Arvadia, sir, and Dr. J.J. Pastagia, sir. Respected Director of Students Welfare, Dr. R.M. Nayak, sir. All the respected resource persons from ICR institutes as well as SAUs, senior professors, scientists, colleagues, participants, ladies and gentlemen, good morning all of you. As we come to the end of the inaugural session of the webinar, it is my great privilege to deliver the vote of thanks. Firstly, I express our sincere gratitude to our Honorable Vice Chancellor, Dr. Deptt Patel, sir. Your gracious presence in this webinar and the foremost visit after honoring the chair of Vice Chancellor of Navsari Agriculture University during last month. Sir, your today's keynote address is like always intellectually stirring, incisive and truly insightful. As you have rightly narrated, the importance of nature resource management is a need of an hour for sustainable agriculture. As the nature resources are the biggest assets of rural communities, their livelihoods primarily depends on the use of nature resources like soil, water and trees. Therefore, management of these resources is critical to sustaining and improving the livelihoods of rural communities generally based on agriculture. Sir, your kind address with profound thoughts and perspectives for this webinar enlighten us. On behalf of organizing committee, I heartily thankful to our Honorable Vice Chancellor, Dr. Deptt Patel, sir, to chair the inaugural function of this webinar as Chief Patron. I'm also heartily thankful to the Chief Guest of this webinar and Honorable Deputy Director General, NRM, Dr. S.K. Chaudhary, sir. Sir, your kind consent to accept our invitation to chair the inaugural function of this webinar as a Chief Guest, and today your thought-provoking address itself indicates your in-depth knowledge. Sir, you have narrated each and every aspect of nature resource management. Sir, your kind words enlighten us and gives new ideas to do better in the field of agriculture. As you are very busy with your different important responsibilities as Deputy DDG NRM to look after all the research activities of NRM at national level, even though DDGs are spared a special time for this webinar. On this inaugural function of this webinar, I am heartily thankful to Honorable Deputy Director General NRM, Dr. S.K. Chaudhary, sir, on behalf of organizing committee. I am also thankful to respected Director of Research of Navsari Agriculture University to be here on this virtual platform, Dr. S.R. Chaudhary, sir, for gracious presence in this inaugural function. Thank you, Dr. S.R. Chaudhary, sir. I am also very grateful to respected Dr. K.G. Patel, sir, Dean Faculty of Agriculture, Bharuch. I want to share with all of you that under terrific condition of COVID-19, under the guidance of Dr. K.G. Patel, sir, we have successfully organized 9 webinars, and this is the number 10th webinar is going on. Sir, you have personally taken care of each and every activities of the webinar that lead to the splendid success of each and every webinar. I thank you, Dr. K.G. Patel, sir, on behalf of organizing committee. I am also thankful to Dr. J.G. Patel and Dr. N.D. Modi is also with us on this virtual platform, the member of board of management for remaining present over here in this inaugural function of the webinar. I'm also thankful to eminent personalities from ICR Institute and especially Dr. Himanshu Pathak sir, Dr. Ajit Singh Nain sir, Dr. Ravi Shankar, Dr. Chinnamuthu sir, Dr. Anand Dipsit, Dr. N.K. Sharma sir, Dr. Gandekari, Dr. Y.P. Singh, Dr. Arejat, Dr. Sekrappa, Dr. D.M. Jetwa, Dr. Lalit Mahatma, and Mr. Newland from Australia, and all the resource persons. I also grateful to respected all the university officers, especially Dr. M. Karvadia sir, Dr. B.K. Srivastava sir, Dr. Pastagya sir, Dr. Sinket Timbadia sir, Dr. Arif Nayak sir, Dr. Ruchira Sukla to be here on this virtual platform with us on the inaugural function of this webinar. I'm also thankful to all the participants across the country and across the globe. At last, I also thankful to one and all who directly or indirectly contributed in successful arrangement of this event. Once again, thank you everybody. Thanks a lot. Jai Hind.
Thank you, D.D. Patel sir. With the permission of chair, we declared this inaugural session become over.
Honorable Vice Chancellor, give the permission.
Okay, thank you so much, sir. Now, this is a time to start our technical sessions. So, Dr. Nain sir soon join the technical sessions. He is a first speaker, expert speaker of today's technical sessions. Before that, I have some of the important points that should be shared with you. So before we go further, I want to review the functionality of this webinar. Your active participation is very much important throughout the sessions. Right now, I have everyone on mute. That because to maintain the decorum of the seminar as well as to avoid the background noise that may directly influence the listening capacity of the webinars. You are also requested to avoid using annotations. That because it becomes very much difficult for speaker as well as listener and viewers. So we are unmute all the participants as well as requested to avoid the annotations during the webinars. We will be running the live question answer sessions at the end of preparations. So we are enable our ask question features. It is on right hand side of the screens. So if you have any questions during the presentations, just pop up them in there. If you have radar to ask any questions personally, you can raise your questions by raise the hand buttons. Then somebody allow you to ask a question personally also, but considering the time availability and the availability of the next speakers. However, time is limiting factor, so we have considered all the matter by considering all the points. So consider matter before raise hand, rather to raise the chat box.
Dear all the participants, today's eminent speakers are with us, Dr. Ajit Singh Nayan sir, Dr. N. Ravi. Okay, Dr. Chinnamuthu sir, your voice is not.
Okay, I will unmute. Good morning. Good morning.
Okay, good morning, sir. Good morning. Very good morning, sir.
Yeah. Thank you very much for inviting me as a first person to talk on this conference. Thank you once again for the organizers. Let us get into my talk. The presentation is nanotechnology application in agriculture with special emphasis to natural resource management. Got exposure with what is nanotechnology and how it is working in other fields like pharmaceutical, electronics, textiles, and other areas, even water management or drinking water like that. The work on application of nanotechnology in agriculture is very much limited. Hope in future it will get a limelight for precision making things in a precise manner to improve the productivity and reduce the cost of cultivation and reduce the any pollution or contamination of our underground water like that. So there is a vast scope in the future, and there is a lot of space for proposing projects for the youngsters who are already in research. Let me continue the topic. Since I worked more on weed management, I will touch upon fertilizer management and seed management, and will give more information with respect to weed management. So let me start. I think hope, yeah, a small introduction about nanotechnology. It is an enabling technology that will change the nature of almost every human-made objects in the next century. Hope you may be knowing now nano car. It is made up of some of the nano materials. Of course, the car is bigger one, but the thing inside is made up of nano materials. That means nano means very small and more accurate, highly effective like that. So in future, almost many of the things are going to be the base material is nano. In electronic industry, see here the memory capacity has gone anything like that. Even a small chip is can able to hold 1 terabyte. In those days, the first when a computer was introduced, 1959, it is occupied the entire room. Now we can have it in our hand. These are all because of the empowered because of the nano materials. So this nanotechnology is an enabling technology. This empowering human being. Even you can become a Brahma. You can synthesize food. You can make carbohydrate on your tabletop without the help of the plants. Also, it is possible. And you can split the water and separate the hydrogen and use the hydrogen as a fuel, so that the entire pollution in the future get eliminated. So in such a way, it is going to be empower all human beings or scientists in a different era in the next era. So with respect to application in our field, especially agriculture, there are humble opportunities. There are a lot of opportunities and spaces are available right now to get into the weed management, get into the management of our inputs in agriculture. So starting from seed, starting weed or nutrient management, environmental management, physiology, you can alter the physiology and improve the photosynthetic efficiency of the crops. Food preservations, you can preserve the food without getting spoiled for a very long time. And nutrition management with reduced nitrogen, phosphorus, potash, or as well as micronutrients, so that you can get a more yield with less amount of nutrients, less with contaminations. And biotechnology, this genome editing, the CRISPR technology, maybe everyone aware of this CRISPR technology that is called genome editing. So they are using some kind of enzymes for cutting the particular the genes and then transferring to someone where it is required. Instead of that, we can use this nanotechnology just to alter the sequence of the amino acid so that we can get whatever the character in the plants itself. So there are a lot of scope in agriculture, and the thing is we have to, our younger generation have to get into that instead of moving up other areas. It is one of the important promising areas, going to get a lot of opportunities and for inventions in agriculture. So let me tell about something on nutrient management. So there are very few institutions are working in the case of nutrient management. So there are a lot of chances or spaces are available for improving the use efficiency of the all kinds of nutrients, especially the macronutrients like NPK, as well as micronutrients and secondary nutrients also. This will see we can use this nutrient, especially with nitrogen. There is one questions: can we convert entire quantity of nitrogen required by the plant into nano form? And if it is applied in the field, means what may be the expensive or cost of manufacturing? Like that, you may ask the thing whether it is possible economically. That, of course, the total requirement cannot be replaced with the nano formulations or nano form of nutrients, especially with respect to macronutrient. But you can go with a little amount as a basal dose, as a starter dose, then subsequent amount can be supplied through a nano form, so that we can reduce the leaching loss, or maybe convert into nitrate form or ammonical form, and losses through volatilizations. So whenever we are, most of the agriculture is going with the controlled release of waters. There is either maybe drip irrigation waters or subsurface, or maybe above surface, or sprinkler methods. So we can regularly use this kind of all macronutrients, convert into the nano form, and only with the starter dose, little amount of starter dose as a basal. So we can reduce more than 60 to 70% of the total nutrient required for the entire crop growth durations. So we can save around 60 to 70% of the nutrient which we are applying right now. This is because of the nano form of nutrients are more efficient. What way it is, it will get absorbed by the plants without leached down in the soil surface or getting volatilized and losing to the atmosphere. So every time, if you go with a little amount of nano formulations, either on the root zone or on the foliar, we can save the amount of nutrients which are inexpensive, or maybe think that in the organic agriculture, the chemicals are dumping chemicals, spoiling the soils, also can be reduced, so that these nanoparticles can be encapsulated, or it can be used for along with the nutrient. Either in the nutrient can be encapsulated with the clay particles like zeolite or carbon nanotube or any other starch materials, so that it will be getting released very slowly to the crop, and it is meet the requirement of the crop when it is required. So even we can use these nano materials to catalyze the soil already fixed amount of nutrient present in the soils. Let's say, especially with the phosphorus, which are already a fixed form, that can be catalyzed. We are using now VAM and other things also. Apart from this, microorganisms, we can use these nanoparticles to release the fixed nutrient to available form of nutrients, so that we can reduce the external application of nutrients. And slowly, nano fertilizers, I said already, encapsulated form of, or loaded with zeolite form of nutrients can be used for slowly released and meeting the requirement of the crop. So timely and accurate diagnosis of nutrients also one of the important area we have to consider, and our university is also working on that. We use color chart, leaf color chart for finding out whether the crop is in their deficiency or it is in required manner. These are all can be judged only after the symptoms expressed, but it may take already led by 2 weeks to getting expression of any nutrient deficiency symptoms. So if you have a sensor which is attached with your plant in a larger area with 1 or 2 plants, it will give you the nutrient content status in the plants, and if there is any nutrient content is going down, means say in the case of rice, the nutrient content of the plant is 4 to 4.5%. So if there is any reduction due to the lack of nutrient in the soils or lack of moisture, the nutrient content may get reduced in the plant. That can be sensed by the sensors, and it will give the instruction to the computer. The artificial intelligence will help us to automatically put on your the drip systems along with the fertigations. So based on the sensors, the requirement can be judged, and little amount of nutrients, required amount of nutrients can be delivered to the needy plants. So this way also we can save the nutrients and improve the productivity with more efficient use of fertilizers. So these are all the areas already some of the companies are attempting, and in the market, if you see, IFFCO is coming out with copper, zinc, nitrogen, and potash also. But all are recommended for the foliar applications in the liquid form. Many companies like TAG and Nano Zinc, Nano Combi, and Nano Potash, Nano Max like NPK, Nano NPK, Organic NPK like that. So these are all already in the market, and the question is whether they are in the nano form or not. Needs to be should go through some norms before getting released into the market and charging it, since because nano they may think that it's really expensive and charge high. The government should have some manner to control this kind of fertilizers or nutrient before getting into the market. Some norms already the ICR and the DBT has set out some norms for 26, 23. The things has to be passed through. So even before the finalize, it is under draft. These norms are under draft now. Even before the draft is putting into the open platform, these companies have come up with nano fertilizers. So we are trusting with the IFFCO nutrients. IFFCO is, I think the Dafadar has given this technology to IFFCO, and IFFCO is manufacturing nutrients based on the biological methods using bacterial culture. So the exudates from the bacterial culture will encapsulate the nutrients so that it can be more efficient and less quantities required. Like this, we are testing in our field right now all the IFFCO nutrients, and we are going to give the final result whether this is working comparatively with the commercial are available and nano nutrient compared to our normal nutrients, and what way it will be better than. Based on our results, and they are going to come out with in a wider way to the farmers through their network, IFFCO network. So these are all developments in the fertilizer industry. And if in seed industries also, there are a lot of furious seeds. It's very difficult to identify the seeds which belongs to a particular variety or not before sowing. But after sowing, based on the morphological characters, we can identify whether the varieties are belongs to that particular number or not. But if you encoding barcoding these seeds during the processing, we can easily identify the furious seeds, whether the seeds are belongs to the particular variety or other repeated seeds are something transgenic origins like that. So seed detection, different seeds from the GM seeds also we can identify. In some of the country while exporting, they face some difficulties, whether the grain or seed or whether it is GM seeds or non-GMO seeds. So by giving this barcode, which cannot be seen by naked eye, can be seen through the scanner, so that we can easily fabricate whether the base origin of seeds and the history of seeds also. And also we can program the seeds to germinate like seed conditioning, pre-season sowing. Like that, we can encapsulate our coating with nanopolymers. So the smart seed or designer seeds are given down in different colors, are coated with thin polymers. This will protect from the pest incidents and the loss of moisture and deterioration of the seeds, and shelf life of the seeds will be increased so that we can use our own seeds for our own purpose instead of getting out from the companies and maybe sometimes expensive. So these programmed seeds are germinate if it is applied on the soils. Whenever moisture comes, means the polymer will disintegrate and imbibe the moisture, it will germinate. So the smart seeds are more useful for the farmers, that too under rain-fed conditions. So this programmed to germinate. So it's based on the moistures. So and the seed hardening coating with this nanomaterials are priming with the nanomaterials. So that now it is this kind of projects are started working in our university itself. Some deficiencies even at the young stage of rice and other crops will appear. Then we'll go for remediating the deficiencies, applying either foliar or through soil. It may take some time. Instead of that, you can prime the seeds with the nano nutrients. That means making the seed more powerful. That means adding nutrient in the form of nano and soaking it or priming it for some times, and especially with the zinc, iron, and copper. This will help the seedlings to grow better. Even within 14 days, the required height will be there, and we can go with the SRI technique, system of rice intensifications, where we need to have a single seed planting in case of rice, and a little bit thicker seedlings are, then only you can mechanize. So the seed hardening or coating with the nanomaterials and the seed priming is more important area. It is this area also we are attempting in our university, and scientists are working with this kind of materials. Then uniform and fast germinations based on all these things. We can get a required number of populations. Since the seeds are selected based on the viability and coated with the polymers and stored in the good conditions, will give more near to 100% germination. So we can maintain the population. That's more important for achieving our target yield. So this is the thing in the management of seeds are going on. And next is in the case of water management. Water management areas are also I'm sorry, this is water management. The title is given bean management. So improving water holding capacity of the soil using a nano gel. So now we have a Pusa gel, Gel Shakti, and other things also. Still, we need to have more efficient gel. Some of the gel available in the markets are expensive, and the number of absorption and desorption of waters are one cycle only. Whether it is can be used for several absorption and desorptions during a growth period of the crop. See, in the case of in rainfed agriculture, sometimes you will get excess moisture. Sometimes the crop will serve starve for deficit conditions. If you're going with a gel which be able to absorb moisture and slide slowly for several cycles, not for one cycle. The gel which is available in the market, we have tested, will be useful for only one cycle. Absorption and desorption is then get disintegrated and may not be useful. The gel which we are developing in our nanotechnology lab, we are developing nano gel from the natural material only. From the waste maize straw and cholam straw, we separate cellulose. From cellulose to we separate the glucose and fructose, and we converting into gel form. That will having a network matrix, knitted network matrix that will absorb water and release water and remain till the end of the durations. And also it won't be contaminated the soil also. After harvest of crop, or sometimes it will disintegrate and it will convert into some other organic form only. So another with respect to water availability, we have many sensors in the market for precision application of water and judging the amount of water present in the soils. Still, we need to have a fine automated sensors for finding out whether the plant is under stress or not. So the sensor which are right now available will give the information about the moisture present in the soils, not the condition of the plants, how much moisture is like, how much nutrient is present. Like that, we have to sense the moisture, whether the crops is starving or not, we have to find it out. So if you join these sensors with the nutrient as well as with the moisture, we can integrate with our computer systems and the drip systems. So it automatically deliver the water based on the requirement of the plants, not based on the soil moisture content of the plants. So improving use efficiency of water, the delivery also. So delivery based on the sensors without wasting water, it will put it in the exact on the root zone. That also done by the computers with the nano sensors. The remediating and the purification of this waste water. Now we have a lot of contaminated and effluent waters, either from a natural stream or from the dam, or the Ganga river is contaminated, and all rivers are all the urban waste are now dumping in the river only. It is going to the again the dam and then project areas. Again, it's contaminating our soils. So these things has to be heavy metals and polluted the chlorination, other pesticides which are present in the soil has to be collected, removed. So this is going to be a very big project. So if you are decontamination, our entire rivers and dams are required a huge amount of the cost and the materials. But it is possible on the field level. Instead of decontaminating on the entire river systems, we can in the individual field level, we can remove all the contaminants using the nanomaterials that can be collected back with the nanomagnets. So our nano activated nanomaterials, if you apply on the soils, it will absorb the contaminants present in the waters, apart from leaving the required nutrients and the minerals present in the waters. It will not take away all the nitrogen, phosphorus, potash. It will remove only the heavy metals and other which are causing troubles or toxic to the soils. So this way, water management also is one of the important area with respect to nano applications. So let us talk about the weed management, the use of or application of nanotechnology in weed management. This is the core area we are working. I am working for the past 12 years, and we have come out a lot of innovative informations and products from this way. We have established the nanoscience and laboratory during 2009, and we have all good facilities from synthesis to characterization of nanomaterials and disposal, proper disposal of nano materials. Also, these three are more important. Only synthesizing either by wet method or dry method, and characterization we need to characterize with the electron microscope, and sample preparation we need to have the block developing methods for tissue characterization under scanning electron microscope or transmission electron microscope, and we have Raman spectrophotometers and atomic force microscope also. So we have all good facilities with the high-end electron microscopes, and as well as safe disposal of used nanomaterials also we have in our university. So we have a separate department in our university, nanoscience and technology department, and our students and our research scientists are working in this area. So in this department, nanoscience and technology department, I was working in the nanoscience department, established nanoscience department in 2000, started in 2004, and full-fledged functioning of nano department comes in action in 2009. So I was there in that department for around 12 years. Right now, in the department of agronomy. Still, I am working. My students are working in this area, and my area is weed management. So, what are the ways and means to apply this technology to control the weeds? So, we a small information about the weeds. This everyone knows. The share of losses caused by weeds is more than 33% on an average. The crop is lost to 33% due to weeds compared to insect or disease or rodents and other things. Weeds causes more losses as well as cost for cost of cultivations. So it is an account about this as per Indians. Our Weeds and Society is giving that Jabalpur annual monetary loss is more than 30,000 crores. So this worth of money is going out because of management of weeds. So and This is some of the issues being addressed with nanotechnology in our university under my leadership. So exhausting weed seed bank. So the cause, we want to manage the weeds. The foremost important thing is we need to stop the raining of seeds. That means stop the weeds going into the soil. The weed seeds which are present in the soil is called weed seed bank. So first we have to stop the seed setting. That means we have to control the weeds and prevent the setting of seeds and getting back into the soils. This way we can reduce the enlargement of weed seed bank. Once the seeds are set and fall in the soils, it will be there in the soil for more than 7 years. So 1 year seeding, it is going to be a 7-year problematic weeding process. So we need to exhaust the weed seed bank so that we can quickly exhaust the seeds with some advanced technology, and we can reduce the incidence of weeds and producing seeds again, enlarging weed seed bank. So for exhausting weed seed bank, there are two important approaches. One is the degrading the germination inhibitors and the exhausting food reserve. Why I am telling the germination inhibitors should be degraded? The weed seeds which are present in the soils are mostly due to dormancy as well as hard seed coat. Apart from the third factor is the germination inhibitors, phenols. The phenols are antimicrobial in nature. So if any materials falls on the soils, it will get degraded very quickly. Even with rosewood or teakwood, if it is having a very high density, it will get degraded very quickly within a year. All the things getting into the soils are degraded by the microorganisms. But if you take the soils, the seeds which are very minute in nature remain in the soil for years together. How it is escaping, how it is avoiding, or how it is coming out of this microbial attack, all the hard materials are getting degraded. Even human or animals or trees are getting degraded. Even your iron will rust away. But the seeds remain 10 years, 20 years, 30 years. Even the lotus seeds will remain more than 1,000 years, the history says. So this is because not only because of hard seed coat or immature embryo or because of dormancy. This is mainly because of the phenolic content present in the seeds, which will kill the organism which are attacking on the particular seeds. So that is the reasons the seeds are remain viable very long time in the soil. That too, even the seeds which are present in the surface soil, that is 15 centimeters, also remain more than 7 years, 10 years. That and the imported custom will remain for 3 years. So like small, yeah, you see in the case of Cyprus rotundus, it's propagated mainly through the tubers. Tuber doesn't have any other seed coat or dormancy or immature embryo. This is remain viable with the soft coat. The scales are there, not a coat at all. The tubers doesn't have any seed coat, but the tubers remain viable because of the presence of the phenolic content. There are 23, we have estimated in our laboratory, there are 23 phenolic compounds are present in the tubers of Cyprus rotundus, which will prevent the damage due to the organisms. So that it will escape from the organisms and remain viable. When there is in a conducive environment, it will germinate and produce new plants. So exhausting food reserve also important area. That means using your technology, but the seed contains starch material. That is food material or food reserve, which will give energy to the germinating plants. So once you are using some technology, if you using some chemicals, some materials, if you exhaust the food reserve, that means degrading the carbohydrate present inside, degrading a phenolic compounds, degrading carbohydrate, directly you can kill the seeds instead of killing the weeds. So our main objective should be kill the seeds instead of killing the weeds after emergence. Once you can, if it is emerged, means it is very easy to kill. But under soil, it's very difficult to kill the seeds. So we need to have some technology to kill the seeds. Then apart from that, if that is weeds are emerged, means whatever herbicides you're applying, it get into the actually inside the plants and reach the where the mechanism is going on. So absorption is either by root or shoot, either maybe a foliar applied herbicide or maybe a soil applied herbicides, it should reach the plants and get into the plants and kill the plants. That's more important. So in the case of, for example, if I quote cypress rodent as, we apply many chemicals, paraquat we are applying glyphosate, but it takes it by the leaf, by foliar applications, it get into the mother tuber. Further, it will not get translocated to the secondary tubers. So the secondary tubers remain viable and put forth new plants in the after 1 or 2 months. So our aim is, if you apply any chemicals on the foliage or to the soil, it reaches entire part of the chain of tubers in the case of cypress rodents, or entire column of the soils to kill the all viable seeds or viable plants or roots. So translocation is more important. Then another important areas, rainfed, smart release of herbicides for rainfed. We doesn't have any herbicide recommendation for rainfed agriculture because the moisture is unpredictable. So we cannot apply in advance herbicide and wait for rain, or it's not possible to go with the irrigation also, since it is because of rainfed area. So a herbicide which remain in the soils without getting affected by any organisms or temperatures or any other means, it remain viable, it remain active. And when rain comes means it should spread on the soil surface and kill the germinating weeds. That also we need to come out with a specific formulation of herbicides for the rainfed agriculture, as well as the slow release for seasonal weed control in the irrigated agriculture, also one of the area we are working. And we also come out with the template for loading the herbicides for smart release in the rainfed agriculture, as well as slow release for seasonal weed control. The rapid degradation of herbicide residue is more important. If there is any residue left in the field, it has to be degraded very quickly. So one by one, I will quickly go through the innovations or informations come out from our laboratory that will be helpful for the students can further work on this area. So weed seed bank, I need not tell about the weed seed bank. It's a landmine. When moisture comes, it will burst open and will germinate and will interfere with the crop growth and take away all the nutrients which are applied to soil moistures. It will get depleted, and that should be enlarged. Finally, it will enlarge the weed seed bank and reduce the yield. So we can use if there is already the plants are escaped. Even after application of herbicide, some of the plants will escape and will grow on the roadsides or in the plants on the crop field. We can use some rehydrating pollen grain so that we can reduce the plants to avoid seed set. That is, sterilizing the flowers. So we can use nanoparticles of, instead of normal sodium chloride, we use normal for managing the case of parthenium. See, consider parthenium, the parthenium flower and the parthenium pollen grain is given in the pictures. So this parthenium plants will produce thousands of seeds per seasons. Within 60 or 70 days or 90 days, it will produce thousands of seeds. Nowadays, everywhere you can see the parthenium. So Indian Society of Weed Science Directorate of Weed Science Research is every year we are following Parthenium Awareness Week and advocating the farmers, students, and other citizens how to manage the parthenium. Since everywhere you can see the parthenium, it can be easily managed with the help of this kind of activated sodium nanoparticle or silver nanoparticle spraying on the plants during flower time will sterilize the plants and prevent the seed set, so that we can reduce the seed set and we can also kill the plants with some other chemicals. So this is then next, we exhaustive weed seed bank with the carbon nanotubes. These are all the one of the important area we are working on this. And using some other, I said the phenolic compounds, by degrading the phenolic compounds, we can induce the germinations. But some of the hard seed coats, which will not allow the our nanoparticle inside the plants to degrade the phenolic compound. In that case, we can use this kind of carbon nanotube. I had heard about carbon nanotubes are used for many purpose, even for making the tennis shuttle racket or space shuttles, everything. So this carbon nanotubes are very, very minute. The diameter of the carbon tubes are 1 nanometer or 2 nanometers or 10 nanometers. So if you apply on the soil and it will mix with the soils, it will get into the seed through cracks, seed coat, then it will channelize the water and this water, once it is entering inside the seeds, means automatically it will imbibe and it will come out with the by germination process. So they can after germinating, we can kill it with either pre-emergence or post-emergence. So carbon nanotubes is one of the ingredient to induce the germination by channelizing water into the seed coat and imbibing the water and initiating the germination process, and then we can able to manage the germinated weeds seeds. This way we can exhaust the weed seed bank. Then another important, I said already, the Cypress rodent is one of the world worst weed, which is noxious and problematic and degrade the all our cultivated lands. Once it is established, and then it's very difficult to manage these weeds. So the Cypress rodent comes up well in the irrigated uplands. So it will produce within a year 80 tons of tubers per hectare if it is uncontrolled growth of. Then it will going on multiply and multiply. Then it will degrade our lands for cultivation purpose. So I said the germination inhibitors and phenolic compounds are present in the plants. There, I said that 23 phenolic compounds are present in the Cypress rodents, which will prevent the degradation through the microorganisms, and it will remain viable in the soils. Once it is the phenolic compounds present in the tubers are degraded, means automatically it will get degraded. So it will die. It will not going to be a seed materials. So in the case of we have estimated that the phenolic compounds are increasing under stress conditions. If seeds are under stress condition, that is under drought conditions, the phenolic compounds are getting increased inside the tubers and will give a mechanism for pass through this tide over this stress conditions. And if there is any rain, the rain will wash away all the phenolic compounds. Then it will start sprouting the new plants, new flush of weeds. So here we have assessed the how much the phenolic compounds are present in the normal tubers and the stress-induced tubers. So important phenolic compounds are caffeic acid, ferulic acid, chlorogenic acid, phenolic acid, and hydroxyl benzoic acid. These are all the important phenolic compounds which will which is present in the tubers and taking care of the tubers under attack of microorganisms or in the stress conditions. So by degrading, we have done with the nanoparticles like iron silver nanoparticle, iron oxide, silver nanoparticles, zinc nanoparticles, and the titanium nanoparticles are synthesized, and we have in vitro, we have analyzed how much it is getting degraded the phenols. So here we have used a different quantity of this iron oxide nanoparticles. So if we use iron oxide nanoparticles, the germination of tubers are very high. 78.7% is inducing the germinations. So otherwise, the germination is very low. That's 40 to 50% of the tuber will germinate, or the new buds will burst open and the new plants will produce. But if you treat this the Cypress rodent tuber with iron oxide nanoparticles, the germination percent is 78.7% compared to zinc as well as with titanium and silver. But the vigor index is also very high. That means it will germinate by degrading the phenolic compounds and will grow very luxuriously. See here, one of the important notable information is if you use silver nanoparticle, the germination of tubers are only 65%, but whatever germinated is very thin and lean plants that may not produce tubers further, since the silver nanoparticles will kill the seeds itself, degrade the apart from phenolic compounds, degrade the another food reserve also present inside the tubers. So we can, germination is, of course, it will remain viable, some of the tubers, and whatever germinated may not able to produce tubers in the next generation because of the degradation of the food reserve present in them. So in the way we can use iron oxide nanoparticle or silver nanoparticles to either to induce germination or to kill the seeds. So this is the way we can reduce the weed seed bank. So we can use other things also. Hydrogen peroxide is one of the very important, very highly active chemicals in the soils, but it's safe to use human being also. It will sterilize the soils. If you go with this silver nanoparticles at the rate of 50% plus 505 ppm of silver nanoparticles, it will act as a fumigant. Apart from this, mostly this kind of combination used for sterilizing the soil medium for nursery and pro nursery, pro-tray nursery or some other farm. So it will kill all the weed seeds also. Accidentally, we found out these treated soils with hydrogen peroxide and silver nanoparticles are free of weed seeds. So we have tested in the field and found that, see, in the case of green gum, we have used this silver, the hydrogen peroxide and silver nanoparticles. There were no weeds even up to 60-70 days. Within after this will complete the life cycle of green manure and the green gram, 90 days, 70 to 80 days, so that we can reduce the viable seeds. That means it will kill the seeds, the hydrogen peroxide. So, but it has to be injected in the soils, so it will get quickly converted to water and lost. So we can use this kind of technology to sterilize the soils or kill the weed seeds, in addition to the nanoparticles also. If you're going with nanoparticles, it will it's a synergistic way it will work. Then another thing is, I said that is we can degrade the starch material or the food materials present inside the seed, which will be the future, the energy is giving for generating the weeds. We can use this kind of nanoparticles also. I said these silver nanoparticles, see degradation of starch is very high. That's why application of silver killing the seeds instead of inducing the germinations. Apart from degrading the phenolic compounds, it will kill the seeds itself. So for killing any kind of seeds, once it is imbibed, if you use along with the silver and the carbon nanotube, so it will channelize the water and channelize the nanoparticles inside the embryo. So this contains the endosperm will contains all kinds of food materials. Starch is the major constituents. So it will get degraded through these nanoparticles and channelized by the carbon nanotubes. So we can reduce the degrade the food materials and will get killed. So improved herbicide absorption also is one of the important area for reducing, increasing the use efficiency of the herbicide. We apply herbicides and the efficiency is only 30%. So if you want to increase the efficiency, we need to reduce the particle size of your herbicides. So already herbicides are, even if it is a liquid form or in the the particle or solid forms, if you divide into a smallest portion, the size of the particles are very big in sizes. We have seen under electron microscope. See, the first picture is the particles, the active ingredient be received from the original active ingredient and seen under scanning electron microscope. So each small round is having one particle which contains thousands and millions of these herbicide molecules. So if you apply, if this is mixed with, even after mixing with water or mixing with whatever may be the surfactant, the size will remain, which is bigger than the pore size of the your leaf surface or on the column, soil columns. So if you apply soil, it has to go through the soil column, it has to enter the plumule or radical, then only the herbicides will active. So either the foliar applied herbicides or maybe a soil applied herbicides, the particles should be very small. So if it's possible to reduce the size of the particle by ultrasonic cutters, by that we can. But what it will do, once it is separated into individual molecules or maybe a cluster of molecules, it will tend to again aggregate. While applying in the field, it will begin aggregate and become bigger particles. To avoid aggregation or agglomeration, we need to have some polymers. The polymer should coat around each individual molecules of herbicides, and it will separate the prevent the agglomeration aggregation, so that it will get absorbed, whatever applied on the soil or applied on the foliar enter into the plant. So absorption is very easy if it is converted into nanoform. Conversion of the nanoform also is not a tedious process. Only simple intervention during a manufacturing process is required. So the encapsulation. So whatever the encapsulation means, what kind of material you are going to use is more important. In the case of see the range of particles we have done here, it's given pendimethalin 16.74 nanometers and fluclorin is 19.95 nanometers. So this way we can reduce the size of the particles and encapsulate it to prevent the agglomeration and increasing the absorption of the herbicides, so that we can reduce the quantity of herbicides applied on the field, so that we can eliminate or reduce the contamination or any other means of things. We can improve the selection also, selectivity also. So it will kill only the target species by the selective mechanism. So we have done with the encapsulation of the glyphosate to find out whether it will be getting translocated to the entire chain of tubers. So we are more concentrating in our research work is management of Cyperus rotundus. So already glyphosate, we know glyphosate is effective in controlling Cyperus rotundus, but we have tested the translocation of glyphosate is taking place only mother tuber. Immediately after germination of mother tubers, it will produce rhizomes and it will produce bulbs, and then the bulbs produce new plants. Like that, the chain goes. So within 36 days, 42 tubers will be produced. In the laboratory, we have found out. So very shortly, more number of tubers will be produced. So once it is applied on the mother plant, it will get translocated to the mother tuber, and the mother tuber will save the secondary tuber or the daughter tubers by preventing the translocations. So we have done with this nanoparticles encapsulation technique and improving the translocation to the entire part of the chain of tubers. So we have studied, if you see here, encapsulated glyphosate is secondary tubers with a very high capacity. It goes up to 1.1 ppm. We have tested. See here in the case of with iron, titanium nanoparticles and zinc nanoparticles, the translocation is 8.1 ppm. So if it is translocated to the secondary tubers, then tertiary tubers means all the tubers will get killed. There won't be any new plants will emerge from the mother tuber or secondary tubers or tertiary tubers. So that we are encapsulating and using this glyphosate, improve the translocation. Apart from absorption, it should get into the entire part of the plants, so that it will kill all the tubers or the chain of tubers present in a family. So this way we have tested. See, you can ask how you did this work. We have cultured the plant Cyperus rotundus in the medium under controlled in vitro conditions. So we have taken the tubers, viable tubers, and used the plants and treated with the. See here, the last picture is with so many with one tuber we have produced about it is hundreds of tubers within a period of 1 month. So we are brushing with one mother plant tuber with the glyphosate, encapsulated glyphosate, and without encapsulation, without nanoparticle also. We found the glyphosate coated with the polymers, along with the nanoparticles, get translocated to the all parts of the tubers and getting killed, so that we can prevent a future multiplication of weeds. So this way we have done. Then I said another rainfall and ecosystem, we slow release and smart release. In the case of rainfall, we have developed a template using the polyallylamine hydrochloride and polystyrene sulfonate, as well as polyvinyl pyroolidone. So these are all the polymers, water soluble polymers. It will form a matrix, knitted fabric like matrix forms. So we can use, there are different types of methods for encapsulation: direct method, indirect method, solvent evaporation method, and also you can use nanospray drying methods also. So among the 4 or 5 methods we have tested for years together and found out solvent evaporation method is the best method to encapsulate the active ingredient of the herbicides. So here encapsulation is done by the polymers. Either we can go with one charge-based polymers or positively charged polymers and negatively charged polymers is having the specific property of water solubles. So it will, whenever moisture comes, it will imbibe and it will enlarge the the knitted fabric, this web, lose out the herbicides. So in the case of rainfed agriculture, we going with 1 coat or 2 coats so that it will get released when rain comes. So in the rainfed agriculture, how it is going to be useful means, say in the case of in Gujarat, if you are going with the peanut means, they will take up sowing in the optimum moisture and allow the groundnut to germinate, and because the topsoil is dry, the weeds will not germinate much for the first first 3 or 4 weeks. So then when there is a rain comes means the seed which is present on the topsoil will germinate and compete with the crops. Once it is crossed 45 days, we cannot go with any intercultural operations. It will uproot the gynapore and will apart the pod formations, and they will not produce pods. So after 40 days, 45 days, you cannot disturb the soils. Either you have to go with the pre-emergence application in the rainfed, you cannot in advance, you cannot apply the pre-emergence herbicide. Or post-emergence, we have to go. Still, we are afraid of going with the post-emergence herbicides. We think that it may also have some toxic effect on the crops or have some stunting effect of the crop. So generally, farmers will go intercultivation operation by any bullock drawn implements or machine. So to avoid this, we have encapsulated these herbicides. We can apply after sowing at any time. It will remain on the soil surface. It will not get degraded by the light, not by hydrolysis, not by hemolysis, not by thermolysis. It can be only by hydrolysis. So the herbicides, it remain viable, active, and when rains comes means it will release and it will spread on the surface of the soils at any time of the crop growth. So take care of the germinating weeds, the pre-emergence herbicide. The same concept is worked for irrigated agriculture also. We are using this irrigated agriculture with the number of coats or more. So more number of coats means it won't release all amount of herbicide is encapsulated into one time. So every irrigation releases slowly for each and every irrigation. Once in 10 days irrigation means it will release the required amount of concentration of the herbicides. Accordingly, we have to encapsulate the quantity of herbicides. So it will take care of every irrigation, the germinating weeds. So you can keep your field free of weed for a very long time. So this is the one of the experiments we have done for sulfentrazone herbicides. So we have synthesized our new formulation of sulfentrazone with liquid as well as with the solid formulations. We are done with the green gram. See here in the pictures, 15 days after sowing and 60 days after sowing. So in the control, there is no crop at all. Only weeds are there. Without encapsulation also, the crops are there, but weeds are there. But in the case of 60 days with encapsulated sulfentrazone herbicide applied, there is almost no weeds till 60 days. Then another 10 more days are there to complete the life cycle of the crop. So we have done this encapsulation with our already developed template. We have a standardized template method for encapsulation. So that is working well with the irrigated agriculture also. So it will take care of germinating weeds in each and every irrigation. It will keep season-long weed control and prevent the seed set and reduce the enlargement of seed bank. So that if you keep it season-long weed control for 5 or 6 years means almost you can exhaust the weed seeds which are present in the top layer of soils. Maybe the weed seeds may be present in the 1 foot depth, but most of the weed seeds are more active is in the surface depth of the 15 centimeters. We can reduce the weed seed enlargement as well as we can exhaust the weed seed bank by each and every time. So this way we can keep our field clean for next after 5 or 6 years. So need not go with any herbicides application after that. So another is the important issue is herbicide residue estimation present in the soil after harvest of the crop. Some of the herbicides are long persistent herbicides like pendimethalin or in this case of atrazine herbicides are remain in the soil for long time. In the case of atrazine herbicide, it long persistence remain viable for 18 months. It remain active for 18 months. Can be get degraded by a huge amount of application, organic manures or farmyard manures, or inducing microbial activity. But even then, it is taking very long time. So first one is we have to detect the residue present in the soils. So we have analytical methods like using HPLC or GC or thin layer chromatography. but that's possible with only limited samples. If you want to test for entire particular district or particular state, means the huge amount of samples cannot be done with your HPLC or GC. We need to have some dipstick method which will give qualitatively whether the herbicide residue is present or not. If it is present, how to degrade the herbicide residue present. So then how much quantify we can done later in the laboratory. So here we using ctDNA, the circulating tumor DNA is called, is a new generation biomarkers. Ethylene bromide is an fluorescent tag. It will give the tag. If it is put under some energy like IR or UV, it will fluoresce. So we can use zero valent ion nanoparticles, either maybe catalyzer ion nanoparticles or any other nanoparticles. So here, like that, it is called maybe it is available in the medical shop for pregnancy test kit. It will, if you are put aliguvate, it will pass through the embedded dipstick, and it will give the bar which is shows that the herbicide residue is present or not. It is really highly accurate, but of course it is difficult to estimate the quantity. But qualitatively, we can say the residue is present in a particular soil or not. This way, it will work better. This dipstick method, this quick method, and you can test very quickly large amount of samples in the in situ itself. You not bring the samples. If you found residue by the qualitative mean this with the dipstick, then you can go with the another means by quantifications. Then how to remediate. So this also possible with the nanoparticles to degrade the nanomaterials present in the herbicide residue present in the soils. So we have done in 2009 itself. So atrazine is used as a herbicide, is being used as a herbicide for bean management in throughout the belt for maize, sorghum, sugarcane, like that. So in sugarcane, it is not a much problem. Since we are going with the redone 1 or 2, 3 redone, it won't be much residual toxicity. But with the maize or cereal followed by a pulse cropping system, the chemical applied in the cereal crop with maize or sorghum may have effect on the subsequent pulse crops. This is because of the herbicide residue atrazine present in the soils. It needs to be degraded. We have done with the ion nanoparticles, zero valent ion nanoparticles. The degradation normally it remains in the soil for 18 months. If it is allowed naturally to degrade, it takes 12 months. But with the use of these nanomaterials, then zero valent ion nanoparticles, within 12 hours, we could able to degrade 88% of the atrazine herbicide residue present in the soils. See in the table, the last column, the time is 12 hours. With the 0.5 gram per liter of the nanomaterials, 82% is getting degraded. And if you add with the 2 gram per liter of the liter in the water and applied in the soil, it's degrading 88%. So we can clear the soils and reduce the herbicide residue, and we can go with the next crop without getting reduced or without getting affected by the residue of previous crops. So these are all some of the informations we have done in our laboratory and outcome of the information. So we are shortly going to come out with the herbicide encapsulated for rainfed agriculture as well as irrigated agriculture. So this is all about my presentation. Thanks for giving the opportunity. So I thanks once again the university as well as the organizers for giving me the opportunity to talk about, tell about the information generated from our university and from my department. Thank you, sir. Thank you.
Okay. Thank you, sir. In the beginning of this, our sir Chinnamuthu Swami sir, we could not read the brief information about the Chinnamuthu Swami sir. So I'm going to give the little information regarding Dr. C.R. Chinnamuthu Swami sir graduated in agriculture during 1983, Masters Agriculture and Agronomy during 1985, and completed PhD in 1990 from Tamil Nadu Agriculture University, Coimbatore. Worked as a PDF in International Research Institute, Manila, Philippines between 1991 and 1994. Dr. Chinnamuthu Swami sir presently heading the Department of Agronomy beside the Director for the Center of Advanced Faculty Training in Agronomy and Professor IFCO Chair worked in various capacities in TNU. Received total 15 awards, fellowship and recognition at national and international level, including Best Teacher and Best Researcher Award from TNU, Young Scientist Award from the APWSS and Fellow of Indian Society of Weed Science. And Chinamuthu Swami sir, on the behalf of the College of Agriculture, Navsari Agricultural University, Navsari, Bharuch, I extend a very hearty thanks to Speaker Dr. Chinamuthu Swami sir, who spared time for this very informative lecture on the nanotechnology. And nanotechnology is the subject everybody always want to learn more about this from this nanotechnology topic. And Chinamuthu Swami sir very nicely covered the topic regarding the seed management, weed management, and germination inhibitors. I'm very thankful to the Chinamuthu Swami sir for accepting little shifting in this presentation also. Thank you so much, sir. So now,
thank you, sir. Thank you.
Thank you so much, sir. For further proceeding, I am hand over the session to the Dr. Alok Srivastava, sir.
Thank you, Dr. Neeraj. So without taking much more time, I would like to invite in this August gathering Dr. Ajit Singh Nayan, sir. He is Director of Research, Govind Vallabh Pant University of Agriculture and Technology, which is in fact oldest and prestigious university, and in fact mother of Green Revolution in India. In fact, Dr. Nayan sir is a versatile personality. Apart teaching, research and extension, he is good administrator too. His expertise in the field of agrometeorology, remote sensing, GIS, crop modeling, climate change, natural resource management, electronics in agriculture, in fact, and precision in agriculture too. He was recipient of German Deptt Fellowship too, and he is instrumental in flagship project of Government of India like Fasal NABARD. He was published several research papers in national and international repo. He was hold several charges in various capacity, like in different organizations, like Officer in Charge, GIS, EduSat, GGH, Geoinformatics, Remote Sensing, Analytical Laboratory 1 and 2. And in fact, he is in charge coordinator of ISRO Outreach Program, Remote Sensing and GIS and GP3. And he was group leader also in Geoinformatics Consortium. So I know him personally, and I know when I was third at IGKV Raipur, he is senior to me. So without much more taking, with all regard and respect, I would like to invite Ajit Singh Nayan sir for kind blessing and address. Ajit Singh Nayan sir, over to you.
Dr. Nayan sir, sorry for interruption. Any dignitaries or participants present over here, if you have any question regarding previous lecture, you can ask the question in by putting the text in chat box. And Dr. Chinamuthu sir is also requested to share your email address and phone number, so participants are directly contact you for any query, sir.
Okay, sir. Okay, okay, on chat box I will spare my phone number. I will share my phone number.
Many have more questions.
And email number.
By considering the time limits, we are invite our next speaker, Dr. Ajit Nayan sir. Sir, platform is yours now.
Even I have been muted, so now, okay. Okay, so thank you very much. The very outset, I would like to extend, the best wishes for the new year. We are just beginning, and I believe that this is the best beginning of the year that you have arranged the webinar, and the response which I am able to see on the screen is quite encouraging. Already 176 participants have logged in. Coming to the topic allotted, let me first share my screen. I hope that now my presentation is visible on the screen.
Yeah, it is visible, sir.
Okay, wonderful. So the topic which has been given to me is geospatial technology for natural resource management. I have a little bit modified it to the geospatial technology for precisely managing natural resources. I would like to take you during 1990s when three frontier technologies have been identified, and those three technologies were biotechnology, nanotechnology, and geospatial technologies. And if you see, the trajectory of the development since 1990s when these technologies have been identified, the different groups and different researchers, those are working. And just before me, the head of the department of Tamil Nadu Agriculture University has given very nice talk on nanotechnology. And nanotechnology has really started taking off with different inventions and the research that is going on in the different institutions. Similarly, biotechnology is also there, and that has started producing the results. And the country has started now gaining the advantage of this technology. Now, talking about the geospatial technology which mostly relate with the remote sensing, GIS, and GPS. That is one technology that has started providing the advantages to the society, to the farmers, to the country. Ever since it started in the country during 1970s when the country started launching its own satellites, and country entered into the space program. During 1980s, then few of very advanced satellites have been launched, and then organized application of geospatial technology started. And that is why during 1990s, the geospatial technology has been recognized by Government of India and other institutions that that would be the promising technology of the future. And the precision farming which we are talking about nowadays, that is basically the result of the geospatial technology that has been applied into the agriculture. Now coming back to some basic things, and just to start with what geospatial technology is. See, geospatial technology basically include the three technologies as I mentioned. The remote sensing. Remote sensing is basically the science and art of taking observation without being in physical contact with the object. And photography is sometimes synonymously related with the remote sensing. But no, remote sensing is not limited to the photography, but there are many more things which which we need to understand and which we need to apply for managing our resources. The second technology of geospatial technology is the GPS, and now almost every person who is using Android phone is aware of what GPS is. GPS is kind of technology which used to provide us location. And location is very important because when you will make survey and when you will gather some information, unless it is associated with the position, then you cannot use that information for large scale planning or large scale development. In the bottom, you can see this. This is the representation of GIS technology, Geographic Information System. And Geographic Information System is kind of a system which used to use the data that is being generated by remote sensing and GPS. So remote sensing is the technology of generating the data. GPS is also technology to generate data, but precisely the locational data. And then the GIS is the technology which will make use of this data and convert the data into the information. You know that the data cannot be used directly for any planning purpose, for any conclusion that cannot be used. That can only be used when the data is converted into information. So the GIS is the perfect system which used to convert geospatial data into the geospatial information, and this information can be used then for planning purpose and for agriculture and allied development. and also the natural resource management. Now coming back to the experiment of your childhood, which you would have done during your schools, and you would have passed through the beam of light through the prism, and then you would have ended up with the different colors. These different colors are basically representing the wavelengths of electromagnetic radiation. And why these colors would be visible? Because these colors are basically having the different wavelengths, and these wavelengths are very, very important as far as geospatial technology is concerned, and especially the remote sensing is concerned. Because these wavelengths, when we'll interact with that object, it will interact in the different manners depending on the nature and properties of the object. And when these are interacting in the different manners, so the reflected radiation can be used to analyze the nature and properties of the object. If you further see these colors which you might have seen during your school, these colors you would have received, and these colors are associated with the different wavelengths you can see. The bottom wavelengths which you received, that was having no kind of violet color or the blue color, and it was having the smallest wavelength within the visible radiation, that is 400 nanometer. When you go a little up, then you will see the increasing wavelength, like at green it is 500, at yellow it would be 550 nanometer. When you will further go up, it would be like 600 nanometer. Then red will end up with the 700 nanometer. So within this visible radiation, though the radiation is not confined to only visible part, but visible is important part of electromagnetic radiation. And within visible, you can see that these are the wavelengths which are associated with visible region. And the blue or the violet is the shortest wavelength, and red being the longest wavelength. Now I would like to take you to these two pictures, and when you will see these two pictures will provide you some characteristics of this object. On the left hand side, you can see that the object is very red, is bright red associated with the yellow colors, while the object on the right hand side you can see is little bluish and little whitish. And this color is telling us something, that the object on the left hand side is very, very hot, because the kind of color which we are seeing and the kind of texture which we are seeing, that is helping our brain to reach on that conclusion that the left hand side object is very, very hot, and the right hand object is somehow related with very cold object. So the color and the textures, these are letting our mind decide as to what object is. And while identifying these objects, we can also draw certain properties, certain natures of this object. For example, the left hand object, we can say that it is having very high temperature. So very high temperature is kind of property of that object. Then the appearance of that object, that is also letting us decide that these are kind of the wooden log because of the appearance. So these two properties we have drawn just looking at the object. Similarly, on the right hand side, we can draw that property, that information related to the object, that this is very cold object and is kind of snow, or you can say ice it is. So that kind of way we can generate the properties of the object. You can also relate this phenomena while you look at any other object. And when you will look at any other object, by looking at the object, you can generate lots of properties, lots of information about the object, and that property, that information can be used then for further analysis, for converting that the data into the information. So remote sensing is all about basically visualizing the object with the help of different tools and techniques which are available, and then generating the data and converting that data into the information. So that is the remote sensing. How remote sensing used to work? How do we how do we see the object that is clearly visible on the screen? See, we cannot visualize any object during night, and the reason is because during night there is no source of radiation. The moment there is source of radiation, either there is light, tube light, or maybe the natural light, then only we can see the object. Why? Because this radiation which is being generated by any object, that will fall on other objects, and then it would be reflected by that object. This reflected radiation would be captured by the eyes, and then that is how we would be able to see the object. Similarly, you can also use the camera, and camera will also work on the same principle. When there is day, you can rely on the natural source of radiation, that is sun. So sunlight will bath the different objects, it will hit the different objects, and then depending upon the nature and properties of the object, certain amount of radiation would be reflected, some would be absorbed, and some would be transmitted. This reflected radiation then will enter into the camera, and then the photograph and the images will be created. So this reflected energy is basically depending upon the nature and the properties of the object, because the first radiation will interact with the objects, and after interaction, whatever radiation would be reflected, that would be basically sensed by the photograph, by the camera, and then the photograph would be generated. Similarly, the satellite used to capture the images. Images are almost similar to the photograph, but only the difference would be that the photographs are basically the true representation of the object in terms of the shape, size, color, texture, etc., etc. While image is not true representation, but it is the likely representation of the object. But images are important because images are generated in the wave bands which are important for the object, which can help you to draw certain information related to the object. So that is why the images are important as far as remote sensing is concerned. Now, if you go by the definition of remote sensing, though most of you would be aware, that is observing the object from a distance, that is remote location. There is no much scientific definition, but if you will go into the scientific definition, maybe at this moment of time, it would be difficult for you to understand. But for the time being, you can understand that anything and everything which you are drawing related to the object without being in physical contact, that is act of remote sensing. So taking image with the help of camera, that is again act of remote sensing. And this is how the satellite based remote sensing is done. Sun, you can see, is the prime source of energy. And when we say the prime source of energy, it is all the time emitting radiation in the multiple wave regions, multiple wavelengths. So visible is one part of the wavelength, but then there are other wave regions in which the sun is radiating energy. But then this energy is not visible to the human eyes because human eyes are only sensitive to the visible portion of electromagnetic spectrum. But that doesn't mean that the sun is only radiating radiation in the visible region. No, it is also emitting radiation in shorter wavelength than the visible, like ultraviolet radiation. It is also emitting radiation longer wavelength than the visible, like NIR, near infrared radiation, middle infrared radiation. So likewise, all the objects which are having temperature, they will emit radiation depending upon their temperature. The very hot object like sun, that will emit radiation mostly in the shorter wavelength, and the colder object like earth, they will emit the radiation in the longer wavelengths. and longer wavelength cannot be visualized by the human eyes because human eyes are not sensitive. The moment radiation would be emitted by the sun, then it will pass through the atmosphere, and atmosphere, you know, that is basically comprising of the different gases, water, suspended particles, etc., etc. So this atmosphere will also interact with this incoming radiation, but this interaction would be very small, and most of the radiation that would be allowed by atmosphere, and then finally that will fall on the land. And from land, because land is having a different kinds of the object, and these objects are varying in the nature and properties, so this radiation would be differently reflected, and then this reflected radiation would be captured by the camera. Those are mounted on the satellites, and from satellite there those images, then those are transmitted to the earth station, and from earth station those are then distributed amongst the users. And this image which you are seeing, no, that is the image taken by the Indian remote sensing satellite IRS-1C, and you can see that no, the different objects can be visualized, and no, these objects which you can see here, these are appearing as if these are no agricultural field, but then the color of these fields are not no resembling what we used to see with our naked eye. And the reason is that because these are the digital image, and these digital images can be then manipulated, or these can be displayed in the different colors depending upon the uses. It is basically the choice of the user. So these digital images are handled with the image processing software, and image processing software will give the flexibility to the user to display it in any color combination. And as far as agriculture and the vegetation is concerned, NIR band is very, very important. NIR band is used for multiple purpose, for identification of the vegetation. It is also used for drawing properties of the object. For example, if you want to analyze what is the amount of chlorophyll, what is amount of moisture in the field, so this NIR band would be important. And because NIR we cannot see with our naked eyes, so you will have to give some color to NIR band. And in this example, we have given red color to NIR so that we can see that if the human eyes are having that power of visualizing NIR band, so how this vegetation will look like. And because NIR, as I mentioned, is important, and it is reflected heavily by vegetation. So because reflection is more, so the human eyes or the system will display that object in that color which has been reflected more. So we had given here red color to NIR band, and that is why the fields, agriculture fields here, those are visible in red color. And then we have also used red band, but to red band we have given green color, and we have also used green band because green, red and NIR, these three bands are important. These three parts of radiation are important as far as remote sensing application in agriculture or plant science is concerned. So we had given blue color to red band, and when you will use this color combination, so the vegetation which will appear would be red. And you can also see another important fact out of this image, that you are getting different tones of the red color, and these different tones of the red colors, that is basically representing the different types of the vegetation and also different stages of the vegetation and different state of the vegetation. So that is depending on the nature and properties of the object. So when you see that kind of differing red color, you can also infer some information related to the object, and how that is inferred, that we will learn in the coming slides. These are now the important reasons of electromagnetic spectrum. You can see the visible has been zoomed and it has been further elaborated. And smaller than visible, you can see these are the ultraviolet radiation, X-ray and gamma rays. And longer wavelength than the visible would be infrared, microwave and radio waves. So the wavelengths, when you will move towards the left hand side, the wavelength will decrease. And when you will move on the right hand side, the wavelength will increase. And wavelength is inversely proportional to the frequency. That means when you are moving toward the shorter wavelength, the frequency will increase. You can see high frequency. This is short wavelength. You can see these are the shorter wavelength. The distance between consecutive wave cycles or peak of the cycle, that is smaller, while this distance has increased in this case. So these are the long wavelength and these are the shorter wavelength. Shorter wavelengths are associated with the high frequency and high energy content. Longer wavelengths are associated with the low frequency and low energy as well. So this is kind of relationship that is existing. Now coming back to the visible radiation, and within visible radiation, we had also learned that the shortest wavelength within the visible is blue or ultraviolet and the longest is the red. And these wavelengths are important for different applications as far as agriculture and allied disciplines are concerned. The blue, which is having shorter wavelength, is important for coastal water mapping, soil and vegetation. Green is important for vegetation discrimination. Red is important for chlorophyll absorption region. NIR is important for vegetation, water body and soil moisture. Middle infrared is important for moisture content, snow, cloud, mineral, rock discrimination, vegetation, moisture content. Thermal infrared is important for vegetation, soil moisture discrimination. And then microwave, these are very long wavelength and that will range from 1 centimeter to 1 meter. That is important for soil moisture. I am again repeating my statement that many wavelengths would be emitted by any object which is having certain temperature, but not all. For example, the sun, which is very hot object, and the temperature of sun, especially of the outer surface, is considered as 6000 degree Kelvin. On that temperature, the sun will emit radiation in ultraviolet radiation, visible radiation and infrared radiation. That sun will not emit radiation in microwave, radio waves and these gamma rays and X-rays because of its temperature. See, any object that is available in your vicinity or in your surrounding, that will emit certain amount of radiation depending on its temperature, and this radiation will depend on its temperature. As to what would be the wavelength of the maximum radiation, that will depend on temperature. If you talk about the sun, which is very hot object, that will emit most of the radiation in the smaller, in the short wavelength, and the peak will come somewhere at 0.55 micrometer or 550 nanometer. Similarly, Earth is very hot, very cold object as compared to the sun, and the temperature, the average temperature of Earth is considered to be 17 degrees centigrade. In terms of Kelvin, it will be like 290 Kelvin. At this 290 Kelvin, the Earth will emit radiation only in the longer wavelength region, only in this region, not in this region. And that is why when there is dark, when there is no radiation from the sun, we cannot see the Earth. Now further the things would be clear from this diagram, that the sun, you can see it is the radiation that is being emitted by the sun, and most of radiation, this is the curve which is representing amount of radiation that is coming from the sun, and the most of radiation is coming around 0.55 macrometer, that is yellowish green region. 7% is coming in ultraviolet, 37 near infrared, and almost 11% in far infrared region, and less than 1% is coming in all other regions. So the sun is contributing maximum radiation in the visible region, and our eyes are also sensitive to this visible part of the electromagnetic spectrum. Now the comparison between the radiation from the sun and Earth, you can see Sun is radiating radiation in the visible region, and Earth is radiating radiation in the longer wavelength. You can see approximately 10 micrometer is the wavelength on which the Earth is emitting the maximum radiation. I know discuss about the interaction of radiation when it will hit any object, and here you can see on the screen the interaction of radiation with the plants. Whenever the radiation will fall on the plants, some amount of radiation would be absorbed, some would be transmitted, and some would be reflected. And this reflection, absorption, and transmission will depend on the nature and properties of the object. For example, if the plant is healthy and is having no good amount of chlorophyll, so it will reflect more in red region, more in green region. And that is why the plant will appear to human eyes as a green object. Now suppose now plant is not healthy, either it is under stress or maybe it has no enter into the physiological maturity stage. At that time the chlorophyll will not be there in the plant, and that is why at that time the maximum reflection will not be there in the green region, but it will be in the other regions, and that is why the plant will appear little brownish at that time. So what I mean to say is this interaction will depend on the properties and the nature of the object. And once we have captured or we have measured this reflected radiation which is coming out from the interaction with the plant, so on the basis of that measured radiation, you can then tell, you can infer, you can draw the nature and the properties of the object. You can quantify these properties. You can quantify as to how much chlorophyll is available, how much nitrogen is available in the plant, how much moisture is available in the plant, how much phosphorus is available. So that kind of analysis you can do on the basis of the reflected radiation. But this reflected radiation should be measured. It should be quantified using certain equipment, certain instrument. And one such instrument is camera. You can see on the screen there are two types of camera, normal digital camera, which you are using all the time, even it is nowadays available in the mobile. And then there is another camera that has been capped on the satellite. This is example of IRS-1C, as I mentioned. These camera would be little different, like the visible, this normal digital camera will have the beam splitter, and then the radiation would be channelized to the different different sensing elements, and then the radiation would be like red, green, and blue, and then the image like this or the photograph like this would be created. Satellite camera will be a little different. Unlike in this case, there will not be a beam splitter, but then there would be four or more different cameras, and these different camera will capture the radiation in the specific wave regions. For example, this camera will capture radiation in green, this will capture in red, this will capture in blue, and this will capture in NIR region. So this is the only difference between the normal digital camera and the satellite camera. So this specific arrangement in case of satellite based camera has been made so that you can quantify the radiation that is coming in the camera in the each band, in the individual band, and this quantification is required in order to establish or in order to analyze the properties of the object or characteristics of the object. Then these images can be generated, as you can see, and these images would be in the digital number. These are the digital images. The digital image in which this the energy which has been reflected, that is represented with the help of digits. And this digits basically tells how much radiation has been reflected by the object. And when you know the amount of radiation that has been reflected by the object in the different regions, in the different wave regions, then you can quantify the nature and properties of the object. Considering that, you can apply remote sensing in different fields like crop inventory, natural resources mapping, nutrient management like nitrogen, organic carbon, moisture stress, pest and disease detection and extent mapping, soil mapping, desertification, salinization, soil degradation, precision farming, cropping system analysis, crop yield forecast, crop growth monitoring, etc. Now, before moving ahead, it would be important to understand this physical basis of application of remote sensing. These are the three important regions of electromagnetic spectrum which are important as far as agriculture application is concerned. This is visible region, this is NIR region, and this is the middle infrared region or far infrared region. If you look at this, the visible region is having very less amount of reflection, and that too reflection in this is red band, this is green region, and this is a blue region. Within this visible region, the green is having the maximum reflectance, followed by red and blue. So that also means that blue is heavily absorbed by the green vegetation, and that absorption will come from the chlorophyll. Then the maximum reflectance would be in the green, and that green reflectance will come again from this chlorophyll, and then there would be red, which will moderately absorb. But contrasting to this, NIR region is having very high reflectance, and then this middle infrared region is having intermittent high reflectance and absorption. And you can see there are three specific regions within this middle infrared region, that is 1.4 micrometer, 1.9 micrometer, and 2.2 micrometer. These are important as far as water in the canopy is concerned. So if you want to determine amount of water that is present in the canopy, you can deploy these bands, these 1.4, 1.9, and 2.2 micrometer. Similarly, if you want to determine the chlorophyll into the crop canopy, you can deploy these three bands, and on the basis of the reflected value, then you can determine as to how much chlorophyll is there. Now, these different objects which you will see, they will produce different types of spectral signature. Spectral signature is nothing but it is reflected energy in the different wave regions. You can see this is the representation of grass. This is the representation of concrete, sandy loam, fallow field, asphalt, artificial turf, and clear water. See, water will absorb most of the incident radiation, but then there would be slight reflectance in the green region, and that is why the water will appear as greenish object when you will look at the water body from the space. And the vegetation to the human eye will appear as green because it is having no maximum reflectance in the green region. But when you will use image processing software, and you will also make use of this NIR band, this is NIR band. See, more than 0.7 is a near infrared region or NIR band. When in NIR band, there is strong reflectance. So when you will make use of this NIR band in image processing software, and you will have to assign some color, like red color you have assigned, so the vegetation will appear as red in the image processing software. Similarly, the different kinds of crops, they will have different types of the spectral signature, and because these are having different spectral signatures, so they will end up with the different types of the colors which you are seeing here. This is like dark red, this is bright red, this is pinkish color, and then you can also see this is very dark red, but then it is also having little different texture. So because of that, you can identify what kind of crop it is. We have deployed remote sensing technique for acreage estimation, and in this case, the Landsat images which are freely available, those have been used And on the basis of the spectral signature, which I just narrated, we identified what object these are. And then by using image processing software, we classified the entire region. This is the region of Uttarakhand, and more specifically, it is Udham Singh Nagar district of Uttarakhand. And then on the basis of that reflectance pattern of the different object, we classified, and then we generated this information consecutively for 5 years. And then we compared our estimates with the government estimates. And you can see here that we ended up with very good R square value and very good RMSE. That too, you can question that R square value is still limited to approximately 0.6, and it has not come down to 9 or 0.9 or 0.99. The reason being is that the estimates of the governments, those are also not very accurate, because those are on the basis of information that is collected from the different sources. And it has been observed that there is variation in the information that is being provided by the government. So that is why this R square, which you are getting here, that is good enough. That is even quite high. But the accuracy you can further analyze when you will verify your results on the ground. So what you can do is, once you have classified the region with the different category, then you can go into the field and see yourself whether the results are accurate or not. And when you will do it like that, then your accuracy would be somewhere 0.95, 0.96 or 0.97. So what I mean to say is that remote sensing can be easily deployed for accurate estimation, and accurate estimation is important as far as the management of resources those are concerned. That is again important for the government agencies in order to frame the policy, in order to develop the planning. So that information is important. Cropping system analysis can also be done with the help of remote sensing technique. And cropping system analysis is done when you have the crop map of all the prevalent seasons in your area. For example, where we are sitting in foothills of Himalaya, where the Pantnagar University is located, it is full of natural resources, full of water. The soil is very good. So here 3 crops are easily possible. So if you are in the region like Pantnagar, you will have to have at least 3 images representing of the 3 seasons. And then you can classify these 3 images for the different kinds of the crop. And then you can put these 3 images together in order to analyze, what kind of cropping system it is. So in this case, the Kharif season image has been classified for Kharif crops. Rabi season image has been classified for Rabi crop. And then the summer season image has been classified for third crop, that is Jayad or summer season crop. And when you will put these 3 together, then you will end up with kind of cropping system that is prevalent in the region or that has been adapted by the farming community in the region. You can see on the screen different cropping system. Here, if you go by the legend, the acronyms of these crops have been used, and these colors are basically representing these cropping systems. So in a short amount of time, just sitting in your lab and performing a few ground truth or few ground verifications, you can easily generate this cropping system information of the larger area. In this case, we have generated it at the district level, but you can also do it at the regional or national or state level just in few hours. But only thing is that you should be equipped with the knowledge, the expertise of geospatial technology, and the tools and techniques those are required, like images would be required. For your information, I would like to tell you that nowadays these images are freely available. So you can just download these images from the net, and then you can start your work, your analysis. Another thing which you will require to do analysis would be image processing software. Nowadays, even free versions of image processing softwares are also available. So now only left is your interest and your expertise. If you have the interest, nowadays there are so many YouTube channel. Even we are also operating one YouTube channel from where you can get the knowledge as to how remote sensing can be operated and how it can be used for generating the data and information. So only your determination is required at this moment, and you can then apply remote sensing technique for different applications. So this is tabular analysis of cropping system. Those are prevalent in the region. See, remote sensing techniques have also been deployed for stress management, for detection of the stress. And in this case, you can see the two lines of reflected curve. Red is representing the stress vegetation. This is stress vegetation. This is healthy vegetation. And green is representing the healthy vegetation. Whenever there would be stress, the reflectance in visible region would be increase, and reflectance in NIR region will decrease. And that in middle infrared region will again increase, because the amount of water in the canopy that will decrease. Here it will increase because chlorophyll content will decrease whenever there would be stress. So this changing pattern in the reflected values, that is kind of indication as to what is going on in the field. And if the pattern is like that, like red color, so you can easily tell that that is the crop is going under stress. Now you can also quantify the stress depending upon the reflection in NIR and red region, and you can calculate the NDVI, normalized difference vegetation index, and the value of NDVI would be indication of the degree of stress. If value is increasing, there is least stress. If value of NDVI is decreasing, there is high amount of stress. So that is how the stress can be quantified. Even you can identify what kind of stress it is. In this case, you can see it is diseased crop, and it is insect affected crop. And when there would be different types of reasons or different types of causes behind the stress, then this spectral curve will change. You can see this red line here is representing the diseased plant, and red line here is representing the insect affected plant. In case of disease, major changes you will see in the visible region. And in case of insect, major changes you will see in the NIR region. So this is how even you can determine as to what is the stress factor. On the basis of that understanding, the Pantnagar University has also developed one innovative approach for disease monitoring in the wheat crop, and the yellow rust has been taken as example. This is the methodology. I am not going into the detail, otherwise it will consume lots of time. But I will just tell you the kind of information that has been provided. These are the maps of two different years or two different seasons, 2007 and 8 and 2010 and 11. So on the basis of remote sensing technique, the yellow rust disease has been monitored, and you can see in 2007 and 8, the most of red color, that is representing that the intensity of yellow rust was quite high. While in case of 2010 and 11, the intensity was very, very less. And then we quantified the amount of intensity, and the amount of intensity you can relate with the the reduction in the yield. In case of 2007, the 93.62% area was under yellow rust, while in 2010 and 11 only 20% area was under yellow rust. And that too during 2007 and 8, this 93.6% area which was there, that was falling in either the red or yellow category. And in this case, the red and yellow categories represent the higher intensity of the yellow rust. And in case of 10 and 11, only 20.7% was affected, and that too the intensity was very moderate, very less. And the result of it was that the the yield in this case reduced significantly. Approximately there was less yield, like 20%, while in the 2010 and 11 there was no reduction at all because of the yellow rust. So you can, on the basis of remote sensing technique, quantify as to know what is the intensity of the disease or any causal factor. Now, on the basis of remote sensing technique and by deploying this statistical techniques, you can also create models for estimation of these intensity of the disease, and then finally working out as to what would be the reduction in the yield. And you can see on the screen that when you will use meteorological factor as well as remote sensing information, so your model would be very robust, and that will provide almost 1 R² value. Then we also compared with the ground truth the information which we generated with the help of remote sensing, and you can see that there is quite good resemblance. This is the ground truth data. That means we conducted survey and then we generated this information. So you can see that this eastern part of the Udham Singh Nagar district is having yellow rust presence, and the same thing is being also provided by remote sensing technique. So that verify the results which you have or which we have developed, which we have generated with the help of remote sensing technique. There is another approach of the growth profiling. So in growth profiling, what you used to do is you used to use multiple images. Those are taken in a growing season, and on the basis of the profile, how the crop is growing. Like this, you can see this is growing perfectly. Here you can see there is dip. Here you can see there are multiple dips. So these dips which you are seeing here, these are representing as to know there is something wrong going on in the field. So on the basis of that growth profiling technique, you can also identify and quantify the amount of stress that is there and then its effect. Moisture estimation you can also do, and for moisture estimation, as I mentioned, these 4 bands are important: 1.4 micrometer or 1400 micrometer, 1.9 micrometer or 1900 nanometer, 2.2 micrometer or 2200 nanometer. These 3 bands are important as far as moisture is concerned. And moisture is important for the reason like Gujarat, because of scarcity of the water. So if you deploy remote sensing technique, you can easily estimate amount of moisture that is present, and accordingly you can use irrigation. Drought monitoring can also be done, and drought is regular phenomena of the states like Gujarat and Rajasthan. So on the basis of remote sensing, you can regularly monitor the state of the vegetation, and then you can quantify the effect of drought. You can see in this case, I have taken the example of 2 different years, and in this case you can see 2010 we estimated the rice yield in Uttarakhand region, and the rice yield was 2.46 ton per hectare, and the rice yield was less because of the drought that was present in the different regions of the Uttarakhand. The abundance of red color is showing the drought condition. So the yield was reduced to 2.46. In other year, 2007, you can see that most of region was green, and then the yield which we received was approximately 3 ton per hectare. So likewise, you can analyze drought. Similarly, you can also analyze flood event. On the screen, you can see the radar sat image which has been taken by the Indian satellite before the event of the flood, and here you can see these lines which are basically representing the Ganges, the river Ganga, and this is the image before the flood event occurred. And then another image was taken when the flood, when there was precipitation, huge downpour, and then the later image shown that there was no water stagnated in the different region. So these blackest patch which you are seeing, that is stagnated water. So that is how you can also assess the region affected by the flood and know what is the status of the flood in the different region. And for that, some specific remote sensing technique like microwave images can be taken even if there is no thick amount of cloud. So these images which you are seeing, radar images, these are the images when these have been taken when there was thick cloud cover in the atmosphere, and these microwaves are having no capability that they can penetrate through the cloud cover, and then they can produce good images like that. So what I mean to say that you can analyze these even flood events. You can also estimate the sowing date on the basis of remote sensing technique, and sowing date information is important. This is the pioneering work which has been done by Pantnagar University. The first model which was developed to estimate sowing date on the basis of remote sensing was developed here at Pantnagar in collaboration with the ISRO scientists. And this methodology provides very accurate estimations of the sowing date. And you know that sowing dates are very, very important as far as productivity of a crop is concerned, as far as phenological determinations that is concerned, as far as the occurrence of the diseases and pests are concerned. So the sowing dates are important. Sowing dates are also important for estimation of estimation of the productivity. So this sowing date determination that helps for the different purposes. You can see this is the estimated sowing dates and the observed sowing date, and you can see these two curves are following one another, signifying the importance of the geospatial technology, especially remote sensing. Here we had linked this remote sensing technique with the crop simulation model in order to estimate the productivity of the different fields. And I would like to tell you that this is the study which has been done at Indira Gandhi Agriculture University, and there was no hailstone events that took place, and these any other technique like crop simulation model or weather-based techniques, these will not capture the effect of hailstone on the crop. But remote sensing technique can capture, because whenever there would be hailstone, there would be physical damage in the crop, and this physical damage, whenever there would be, it will change the reflectance pattern, and this changing reflectance pattern will basically tell you as to what is the amount of destruction that has been put into the field by the hailstone. So you can quantify, and then you can account your model for these losses, and then you can provide very good estimates. Remote sensing can be used for land use and land cover, for slope map, for aspect map, and that data or that information is important for suitability analysis. This is one reason, one area where remote sensing and GIS, those can play very important role. If you are interested in finding out as to what crop will suit to what location, suppose you are interested in Gujarat and you want to introduce a new crop into the Gujarat, so you can use remote sensing and GIS together. You can use the data like meteorological data and kind of soil, kind of topography that is there. Then you can also use you can also determine length of growing period, and then all these factors you can combine together, and by developing some smaller models in the GIS, then you can identify which region will suit to a particular crop. Here you can see we analyze the suitability of fast growing tree species like poplar and other tree species which can be grown in the different regions of the Uttarakhand, by providing weightage to the different parameters, and then we ended up with that kind of map. And these colors are representing the different kinds of the suitability, different levels of the suitability. For example, this color is most suitable category color, And that means these regions would be more suitable for popular, and likewise other colors. Then some other species have also been analyzed, like willow has been analyzed, eucalyptus has been analyzed, pine has been analyzed, acacia has been analyzed, and then finally these individual analysis or individual maps have been clubbed together in order to find out which region will suit to which species. So that kind of analysis can also be done for different crops for any reason. Hydrological modeling can also be done in order to identify the watershed in the regions and availability of the water. And then you can also analyze the erosion potential. And once you know the natural resources, those are available, and then the potential, the erosion potential, then you can prioritize these different watersheds depending upon their characters. And here in this case, we had worked out the watersheds of Nainital district. This is Nainital district and this is Udham Singh Nagar district. And by assessing all the natural resources, then we prioritized these watersheds. And this information then can be passed on to the governmental agencies. Remote sensing technique together with GIS can also be deployed for agroclimatic zonation. And needless to mention that how important this agroclimatic information is. See, your all planning should depend on agroclimatic zonation. You can also do agroecological zonation by incorporating few more parameters like length of growing period or precipitation distribution index. And then you can also work out the agroecological zonation. And agroecological zonation is very, very important as far as your agriculture planning is concerned. Similarly, these techniques can also be deployed for methane emission. In this case, remote sensing and modeling, these have been integrated for estimation of methane emission from the fields. We have also used remote sensing for soil mapping. You can see the soils of the Nainital districts have been mapped, analyzed for different soil properties, and then combined soil fertility map has been created. And this information then has been provided to the farming community through web-based soil information system. So this was the kind of first web-based soil information system that used to provide information to the farming community related to their location as to what kind of soil is existing, what are the different properties, available nitrogen, available phosphorus, available potash, then the organic matter, thermal regime, water regimes, soil depth, soil pH. So that information is provided to the soil, to the farming community just on the basis of one click. So this web-based information, soil information system is playing a very crucial role as far as agriculture operations are concerned. We have also converted that into the Hindi version, and then the Uttarakhand Bhusuchna Tantra has been created, considering that the farmers are not able to understand the English language. Then the same set of information was also used in order to create agriculture expert system. And again, it is web-based system. This agriculture expert system used to provide the advices to the farming community, what need to be done and what need not to be done on the basis of current conditions of the field and on the basis of the weather forecast. So it first tells the current conditions, then it tells the weather forecast for next 5 days, and then on the basis of that it used to advise what should be done in the field. So it is kind of macro scale precision farming. These are the different snapshots of this precision farming that is web based. Then another system, this is Android application. The system has been used, and in this case also the remote sensing and weather information has been used. And this is kind of Android app, and Android app can be used by the farmers. You can see this is the snapshot of the Android app, whenever the farmer will try to use this app, it will collect some information from the farmer's field as to what kind of crop he has shown, what is the current status, and then on the basis of remote sensing information and certain modeling, it used to provide the status of the disease and insect in the locality of the farmers. And this locality of the farmer, or from which region this app is being used, that information is generated from this GPS module, which is inbuilt in the Android system. So on the basis of that, we used to draw where the farmer is. On the basis of certain preliminary information, we used to create the map. And on the basis of remote sensing technique, we used to analyze what is the current status. And then on the basis of the weather forecast, it used to advise the farmer that in coming days, this would be the status of the disease and insect. And if this is that, then what kind of chemical should be used to protect your crop, that is also advised. You can see the query result is there on the screen. So this is when the farmer will make use of this Android app. So he will get the information as to this is the problem, yellow rust, and this is the solution. Till should be used at this rate. Then the wilt is also prevalent, and this should be used. So caterpillar is also available, and noxacarp should be used. So this is kind of the potential that the geospatial technology is offering too. These are the different snapshots of this Depptt's Android system. It is also working with simple text messaging system like the SMS. Through SMS can also the system can be accessed and used by the farming community. Now we are moving towards the automation of the system, and we are into the process of developing a fully automated system, and the system which will work with the help of the camera that is available in your mobile set. So a system has been designed that when you will access that system, it will ask you to capture the picture, to take the photograph of the region in which you are interested. And whenever you will take the picture, first it will identify what kind of crop it is. Then it will also identify on the basis of photograph what kind of stress is there. And when it is determined as to what is the stress and what is the intensity of that stress, then it will also advise what should be done. You can see here the example of one disease, that is yellow rust. So when the picture of yellow rust has been taken by the camera of your mobile, then it has classified like this, and then it analyzed, it determined that yellow rust is there on the crop. And once it has determined that what is the disease or what is the insect, then it will suggest as to what kind of measure can be taken. This is the example of powdery mildew. You can see, and that is how the farming community can be advised. The last application which I will discuss is the role of geospatial technology in precision farming. I had mentioned that the remote sensing can be used to determine the nature and properties of the object. So the same can also be used to determine the soil status, the available nitrogen, available phosphorus, potash, organic matter, amount of water, amount of moisture in the field. And on the basis of that, once you have determined the status of the soil, and if suppose you are integrating it with the STCR approach, that is soil test crop response approach, and soil test crop response approach talk about the targeted yield of the crop. So you can target the crop yield, and you can fit that. These are the equations. You can fit that targeted yield, and then on the basis of the available nitrogen, phosphorus and potash, it will tell you as to how much additional nitrogen, phosphorus and potash would be required. and where it would be required, that also be informed by the system. And that is how you can do the precision farming. This is one example of precision farming where the maps of these different soil properties have been created, and then on the basis of this soil map and this STCR approach, then the farmers were advised as to how much input should be applied and where it should be applied. So this is one case of the farmers field and the university field. And you can see this is experimental field where one part has been kept for precision farming and another has been kept for traditional farming. And then the difference which you can see within this precision farming plot, not only the higher levels of the yields were achieved, but then there was quite homogeneity across the field. The crop condition was same, the crop was very healthy, and that is how from 4 different regions from where we collected the data, these were quite homogeneous as compared to the traditional farming field where the yield levels were less and also the heterogeneity was there. So this is the example of the farmers field. This is the field of farmer just close to the university, that is Kalinagar village. And here we advise the farmers. You can see these are the different operations. Those have been taken by the farmers on the basis of our advice. He is the farmer who opted for this precision farming. And when he compared the field which has been managed with the concept of precision farming with that without precision farming, he himself measured and he informed us. It is not we measured, but he himself measured. And he told us that in the precision farming plot, he received 24 quintal per acre wheat yield, while non-precision farming plot, he measured only 20 quintal per acre. So this is the potential of the geospatial technology. We have not increased the level of input. Only thing is the level of inputs have been intelligently managed. When these were required and where these were required, these were applied. So just by doing it, just by adjusting your inputs, you can increase your productivity substantially. So this is kind of the potential that is being offered by the geospatial technology. I think I have taken too much of the time, and now it is time to say thank you very much for giving me patient listening. Thank you very much. I would also like to thank organizers, especially head of the department, Dr. Patel, Dr. Srivastav, and Dr. Neeraj, who have been instrumental in making me present at this moment and interacting with the participant. Thank you very much. I have taken a little more time than expected. Sorry for that, and another sorry for little adjustment in the lecture schedule, because I stuck in a meeting which was to end by 10 o'clock, but then it went on and it was important meeting. So thank you very much for all adjustment which you made. Thank you very much.
Thank you, sir, for I know there's no need to say sorry. I know your schedule is very tight, and as far as Pantanagar is concerned, I know what kind of schedule is there. So without taking much more time, so thank you. Thanks a lot for delivering a wonderful lecture on geospatial technique and its application in agriculture. Sir, in fact, you have started your lecture from very basic route. What is, in fact, remote sensing? What is GPS? And how it is geospatial technology is, in fact, intervene in day-to-day work. You explain very well different tones of red colors in context of various vegetation growth and how to interpret the same. You also talk about electromagnetic radiation from the sun and related curves. You explain RTA, that is reflection, transmission, and absorption of radiation in different physiological stages of the crop, and its interpretation in its interaction with plants in very easy manner, sir. Sir, in fact, you have covered A to Z. In fact, it is very difficult to cover the things, but you have covered all the things in nice manner, sir. You explain what are the physical basis for application in agriculture. You talk about estimation of sowing date, how we can, with the help of this remote sensing, how we can estimate the sowing dates and what kind of impact is there. You talk about remote sensing, CSM, that is crop simulation model, and integration for yield forecast. You talk about suitability analysis and many more. So I know this is a lunch time for you too. So without taking much more time, one from behalf of this college and personal my behalf, thanks a lot for delivering a wonderful lecture, sir. And now I would like to call Dr. Neeraj for a vote of thanks. Over to Neeraj.
Thank you so much, Alok sir. Before going on to this vote of thanks, I would like to ask the participants, is there any question? Is there any query regarding Nan's presentation? Okay, so I think there is no question. Sir, Dr. Nan sir, actually I was doing PhD, I completed my PhD from the Pandnagar, and during my PhD, Dr. Nan sir was my pioneer, my guide, and Dr. Nan sir guided me a lot. And sir, actually I would like to give the little information about this, the work is doing by the Dr. Nan sir. Dr. Nan sir is doing a great job in the field of agriculture and meteorology. Dr. Nan sir is doing a very pioneer, very nice work in the field of the remote sensing and geospatial technology. If you go through the research papers, the published by the GB Pant University of Agriculture and Technology under the guidance of the Dr. Nan sir, you will see the work is the pioneer work. The work is been used by throughout the India and abroad also. Actually, Dr. Nan sir very nicely covered all the related topics regarding his presentation and about the image processing software. And Dr. Nan sir very nicely explained how we can use this remote sensing technology by the using of the minimum resources. We can download the free of satellite pictures are available, different free of cost, free downloadable softwares are available. So the work is only for the expertise. If we have the sufficient expertise with us, we can do this remote sensing. And if we talk about the doubling the farmers' income in our, and they're doing the very ground level work and grassroots level work, and they are directly beneficial for the farmers and the researchers also. And this remote sensing technology, whenever we see, it seems to be very, very difficult technology. But under the guidance of the Dr. Nan sir, I have been guided by the sir. We very easily we can use this technology to the farmers and for the researchers also. So I would like to thankful for the Dr. Nan sir for very nicely covered all the relative information about the remote sensing technology. And I would say I'm very thankful to Dr. Nan sir for sparing his valuable time with us on the behalf of the College of Agriculture, Navsari University, Bharuch, and on the behalf of the organizer of this webinar, I would like to say thank you so much, sir. And I'm very thankful I got this opportunity to say thank you on this international platform, sir. Thank you so much, sir.
Thank you very much. Thank you very much. Thanks a lot. Bye-bye. Good day. And all the best for rest of the lecture and rest of the session. Thank you.
Thank you so much, sir.
Thank you.
Yes. Our next speaker is Dr. N. Ravisankara sir. His topic is on role of integrated farming system in natural resource management. By considering the time limits, I have dropped the brief biodata of Dr. Ravisankara sir in our WhatsApp group, sir. So I no need to repeat the same over here. I'm directly invite Dr. N. Ravisankara sir for his presentation and talk, sir. Dr. Ravisankara sir.
Yes, good afternoon to all. Hope I am audible.
Yes, sir. You are too much audible and your screen is visible too.
Too much audible. Okay. So very good afternoon to all. Considering the time limit, I would like to very briefly tell about what is the role of integrated farming systems in the natural resource management. I think this is lunchtime. Hopefully everybody will be hungry and it is not wise to take your more time. So I would like to very briefly tell, just to give the overall brief about the Indian agriculture currently going on. It is 2.4% of the world land is supporting the 17.45% of the world population, and roughly half of our area is under the rainfed area, suffering from the resource crunch of capital investment, land, and also the water in terms of rainfall. And the out of the 20 agroecological zones, the 8 agroecological zones are having the less than 150 days of length of growing period. So if you look at the scenario of Indian agriculture, there are opportunities, there are also constraints, there are also threats related to the climate related aspects. And it is estimated that our food production, we need to increase up to the level of 405 million tons to meet the 1.7 billion tons, 1.7 billion population in the year 2050. So we are at the very critical juncture of almost increasing the food production by 1.8 times. And if you see, almost 239 districts, they consume less than 100 kg per hectare of nutrients. And their productivity is highly limited due to the less application of the nutrients and also the less application of the resources. Whereas in some other districts, the remaining districts, whether the use of fertilizers or use of inputs are either at the standard level, standard recommended level, or at the higher level. So this is the current scenario of the Indian agriculture. When you look at the Indian farming systems as a whole, almost 80% of the households are having the only 2 to 3 components, having the crop and dairy as the major component in this one. And when we compare these 80% households resource use efficiency with that of the remaining 20% of the households having the more than 3 components, maybe 3, 4, 5 components, if you see the efficiency in use of these resources such as water, land, and also the other capital money, whatever is invested on the agriculture. If you further divide these 80% households, there are 59% farm households. They have only 1 to 2 components. They are using because our Indian agriculture is traditionally a crop plus dairy farming systems, and not with much of diversification. And due to the emergence of the green revolution technologies and also the marketized input agriculture, marketized input based agriculture, our agriculture moved to the crop oriented systems and reducing the allied activities in the farming. So with this, the 59% of the households having the less number of components are not able to use their resources effectively or efficiently in terms of land, labor, capital, and everything. And because of that, the currently we are talking about the national level priorities such as improving the soil health, or the reducing the use of mineral fertilizers, or the increasing doubling of the farmers' income, so on. So all these priorities are being set due to these type of problems in the existing farming systems. So when we go for the integrated farming system, it is not a new concept to the India. You know that it is a very it is practiced in time memorial by our forefathers and the farmers, but due to the requirement to increase the production of the food grains, especially cereal, pulses, and oil seeds, our focus was towards these crops, which resulted in the monocropping or the cereal intensive systems such as rice, wheat, maize, wheat. So all these kind of actions related to the resulted in the reduction in the partial factor productivity of the applied inputs. For example, in the earlier days, for each kg of nitrogen applied, we used to get around 15 to 20 kg of grains. Now, that has declined to the level of 3 to 4 kg of grains per kg of the applied inputs. So similar is the case for the other inputs which we are applying into the agriculture systems. So in order to enhance the efficiency of the production system as a whole, the integrated farming systems play a critical role in addressing the several issues like increasing the income and reducing the expenditure, because the market inputs cost is increasing, because of which the agriculture is becoming a less sustainable, and the increase in employment, because nowadays the self-employment is also a major problem, especially in the COVID-19 pandemic situations. The reverse migrations are happening. So increasing the rural employment or the self-employment is also a critical. And the emission related issues like in India also, the around 27 to 30% of the emission is contributed from the agriculture alone, out of which the major contributor is the livestock component due to the enteric fermentation, this one. So that's why this we need to plan in such a way that our agricultural activities really leads to the reduced emissions, and also we should also inculcate a mitigation options, climate related mitigation options to reduce the risk. So if we are able to achieve all these four main pillars of this sustainable livelihood, then it is possible to sustain our Indian agriculture system with a higher natural, better improvement in the productivity of the inputs which we are applying, at the same time conserving the natural resources which are very critical for the sustaining the agriculture in future. So this is possible through the integrated farming systems by ensuring by appropriate combination of minimum competition, selecting the components with the minimum competition, maximum complementarity, sustainable and environmental friendly production technologies incorporation, and maximum recycling and reducing the market dependency and increased. These are all the certain criteria on which the components should be selected for the intentional integrated farming systems. And the earlier, whatever the farmers are practicing, they are called as the natural farming systems, which are low productive, low use of resources, whereas these intentional integrated farming systems aims for the higher productivity of all the applied inputs, and also the increasing the income and sustainable livelihood of the farmers. So when we have analyzed the characterization of the different farming systems using the farming system typology analysis, so what we found is that existence of around 6 major farming systems in the entire country. Like cereal based farming system is the topmost farming system practiced in our country by the 32% of the households having the mean area of 0.74 hectare, followed by the other than cereal crops intensive farming systems. And similarly, the livestock based integrated farming system is also practiced by 17.7% of the households. And if you see, look at these figures in Gujarat, these pie charts indicate given in the Gujarat state, it indicates there is two different kind of farming systems existing in the Gujarat conditions. Like in northern Gujarat, the livestock based integrated farming system is predominantly practiced by the farmers, wherein the livestock based integrated farming system needs to be refined with the appropriate integration of the agroforestry components and other important components to reduce the emissions from the greenhouse gas emissions from the existing farming system, and also sequester more carbon. And in case of southern Gujarat conditions, if you see, they are diversified crop based farming systems having the lesser income, and also we need to integrate the appropriate combination of the commercial crops in the existing farming systems to enhance their productivity and profitability. So here in case of farm typology analysis, which we have made for the entire country, for the different districts of India, based on these 6 major farming systems, we found that there are several determinants which finalizes the which in fact makes up the making of the farming systems. like cereal intensity, pulse intensity, cost of crop cultivation, and also the dairy yield. There are several factors which influences at the local level, but at the country level, these are all the major factors which determines the particular type of a farming systems in the existing scenario. And in this particular chart, if you see the 2 districts data which is reflected here, the Mehsana district, wherein the third number is, that is livestock based integrated farming system is highly predominant in this particular region, while in Panchmagal district, the diversified crop based farming systems is highly predominant in the case of whether other than cereal crop intensive or the diversified crop based farming systems are highly practiced by the farmers due to the several factors. And what we have done this one under the AICRP on integrated farming systems at the all India level, by using a common methodology of selection of components, allocation of the resources, natural resources such as land, capital, and other parameters like water, energy, everything. We have designed a intentional integrated farming system models for the different regions of India, and in which we have developed all these models to use the resources, natural resources, in a sustainable way. Like in cropping system modules of the integrated farming systems, we go with the 4 kind of cropping system groups, wherein one particular cropping system is designed mainly for the soil health point of view. The second set of cropping system is designed for the family nutrition to meet the cereal, pulses, oil seeds, and also the other requirements of the household members. Then the third set of thing is that income generating module to support the social activities like education, extension, education, and also the other social events, health, and all other parameters. Then the fourth one is the livestock nutrition, because our livestock population in India is suffering from the round the year fodder, the less availability of the green fodder and also the dry fodder availability during the lean season period. So all these farming systems which we have designed across the country are taking care of all these aspects: soil health, cropping systems, family nutrition, and income generation, and livestock nutrition. These area for under the cropping systems are appropriately allocated for these purposes under these farming systems. And we also go for the allocation of the area under the fruits, plantation crops, or the long-term crops like coconut, mango, guava. This type of orchard plantations are taken up in the 19% of the area, that is roughly 20% of the area. Once we integrate this type of long-term perennial crops, whatever the emissions which are coming from the livestock component can be very easily neutralized, and all our models are found to be emission neutral, or the more carbon sequester, more sink than the source for the emission. Then the other activities, supplementary and complementary activities like apiary, mushroom, boundary plantations, kitchen garden, all these can also be integrated into these intentional integrated farming systems. This is some of the identified potential cropping systems for the different purposes in the different ecosystems, which is having the soil health, that is the land and the increasing the land use efficiency, and also the soil health, which is the very critical for sustaining the farming systems in future farming systems. So we have taken care of this in such a way that these cropping systems, which are designed for the different ecosystems, are inbuilt into the integrated farming system to take care of the natural resource, that is a soil productivity and also the soil fertility. Once the legume crops are grown in a rotations under these farming systems approach in a rotational, maybe income generating crops are grown in a strip for 3 years and then followed by a one year of soil health cropping systems. This way the soil health, the soil resource is saved or the sustainably, suitably maintained for keeping the productivity and productivity at the higher level. So far we have developed 60 prototype integrated farming system models by involving with the ICR institutes, SAUs, and also the central universities. In Gujarat also, Navsari also, we have center. The IFS model development is in process, while the other locations like SK Nagar, we have already built up this IFS model, prototype IFS model at the Gujarat locations. And all these models, whatever the integrated farming system models which we have developed, is addressing the several issues which are of prime importance nowadays, in a holistic way, in a systems approach and in a holistic way, like doubling of farmers' income. These models provides the income, increase the income by 3 to 5 times, which I will explain state-wise later on. Then these models also helps to reduce the mineral fertilizers and improves the soil organic carbon, which is very critical for maintaining the soil microbial properties and also the supply of nutrients, steady and readily available nutrients to the crops. And these models are sustainable, highly sustainable. That means it is taking care of the natural resources which are required for the agriculture. Then the household level human nutrition and also the livestock nutrition is ensured, because area allocation and also the selection of components are taken into consideration or decided for that particular region based on the average family size and also the livestock size requirement, and also the as per the ICMR, that is Indian Council of Medical Research, recommended nutrition diet is followed while deciding the cropping systems and crops. Then this is the particular model which we have developed for the Gujarat state, wherein the diversified cropping systems are integrated with the fruits, this buffalo, agroforestry, and also the boundary plantations. This can give more than 2 lakhs rupees per year per hectare. And also the BC ratio is much higher compared to the normal activities like cropping systems alone or the dairy activities alone. It can also generate around 349 man days for employment, self-employment for the family. Then we are also creating a simultaneously in order to have a healthy farming systems in this one. We are also promoting the development of this integrated organic farming system clusters in various states involving the farmers. These type of integrated organic farming system clusters or the high integrated organic farming system concept helps to get more energy, more output energy. And also it is almost, if you see here, energy input from the input here is only 25.8 multiplied by 10 to the power 3 megajoules, while it is giving the energy output of 3 times. It is almost 3 times higher energy output, employment, and also the output in terms of income. Then there is a concurrent improvement of the soil physical, chemical, and biological properties due to this type of integrated farming systems or the integrated organic farming systems concepts. Because once we apply only the mineral fertilizers, the chemical properties of the soil only gets changed, altered, rather affecting the deteriorating the physical and also the microbial properties of the soil. While these type of integrated farming systems or the organic farming systems helps to concurrently improve all the 3 properties of the soil, and that helps for the improving the sustainability of the farming through the integrated farming systems. And we also these sustainable development goals which are set to be achieved by the year 2030, out of 17 sustainable development goals, that takes into care of the natural resources, natural resource management also, including the life on land, zero hunger, this responsible consumption production, affordable and clean energy. All these kind of natural resource based sustainable development goals can be addressed through the integrated farming systems. And out of 17 sustainable development goals, 13 SDGs sustainable development goals can be addressed through this type of intentional integrated farming system, which are designed for a particular purpose. And at the household level, these IFS can address 13 SDGs, while these integrated farming systems are implemented in a landscape level or at the territorial level, it can cover all the 17 SDGs. It can address all the 17 sustainable development goals, because the quality education. Yeah, somebody is playing something. Should I continue? Excuse me.
Yes, sir.
Should I continue?
Yes, sir. Yes, sir. You can continue. However, as much as possible, you can restrict yourself.
Okay, okay. No, somebody has played some this one. No, just I just. Okay, this peace, justice, and all these type of things can be done. And the mineral fertilizers, we have found that through the integrated farming systems, the use of organic manures gets increased due to the recycling. And also we can save up to 45% of the urea, 41% of the DAP, and for 66% of the MOP on per hectare basis. And this results in the national level saving also, and also improvement in the soil health. And we have seen over the years several of our models, the soil organic carbon has increased from low to medium, and also the medium to higher level. And these type of practices also helps to improve the earthworm count in the by increase by 32%. The microbial biomass carbon, which is very critical for, which is determining the availability of the nutrients through the mineralization, is also enhanced due to this type of integrated farming systems through the resource saving. And across the different agroecological regions also, it is found that around 27% of the soil organic carbon can be increased due to the practice of these integrated farming systems, and microbial carbon by 8.9%. And compared to the monocropping or the predominant cropping system based this one, the energy efficiency can be doubled, more than the use of energy. With less energy, we can produce the more amount of food for the human population in our country, human, and also the fodder for the livestock also. You can see the sustainability of these IFS models are very high compared to the cereal based cropping systems like rice, which is having only 0.47, while these IFS models are having the highly sustainable because these models uses the resources in a sustainable way. And some of the vertical farming modules also we are integrating with the existing farming systems in order to utilize the resources, land resources, in an effective way, because the horizontal growth will be very much restricted in terms of land due to the competition for the developmental activities in like infrastructure development, residential areas, and also cities development. So we need to concentrate on the vertical development of this vertical use of these resources, like especially the land resource. So in this case, the vertical farming modules also forms as an integral part of these intentional integrated farming systems in order to meet the requirement of the various requirements of the human, livestock, and also the natural ecology. Then apart from this, whatever the advantages which I have given, there is a saving in market input cost. In different farming systems, it ranges from the 42 to 72%, which is happening mainly due to the recycling of these residues from one component to the other component. So with this, due to the reduction in the market input cost, that sustainability of the farming systems increases. Then Apart from these, some of the areas you must be observing that waterlogged areas are available in many of the coastal areas, wherein only one crop is grown, only rice is grown. After that, land is kept as a fallow. So those areas can also be, the land resource in those areas can also be utilized effectively by way of a land configuration based farming systems like raised and sunken bed system, 3-tier systems, or the broad bed furrow systems, wherein the rice and fish is grown in the furrows, while on the raised beds, vegetables or any other fodder crops can be grown throughout the year. That type of a land configuration based models also helps to conserve the water, utilize the properly, and improves the water productivity of the soil. And this IFS concept also promotes the diversity of the crops grown in the farm, which directly or indirectly helps for the biological nitrogen fixation, and to the tune of 120 kg of nitrogen per hectare. That is a very good natural resource. That is natural nitrogen fixation from the atmosphere through the microbes or the diversity of the plants is also helping to conserve the soil health and keeping the soil health in a better way. And these type of farming systems relies mostly on the renewable sources of energies like recycling through the compost, and also the biogas production, and other use of solar energy, etc. The water productivity gets doubled, and also it creates the round the year employment for the farm family. And the diversity index, which we have worked out for across the different models, it indicates that the diversity increases to almost 0.82 compared to the 0.1 or the 0.05 in case of the monocropped areas. So in this case, the diversity helps in several ways. One is the biological nitrogen fixation. It also helps for the reducing the pest and diseases. It also enhances the natural enemy population in the field, and try to maintain the ecological balance in the agriculture through this type of integrated farming systems, and which contributes for the stability as well as the sustainability in terms of income, in terms of resources. Then we also measure the ecosystem services like provisional, regulatory, and economic services, which are very important. The models, the scientifically designed IFS models can contribute for all the services which are essential for the sustainability of the natural resources in agriculture, through the agriculture. So in these IFS models play well integrated components based IFS models can provide ecosystem services that can benefit the ecology and also sustainably maintain the natural resources. These models also takes care into the local resources, local or the national, these native breeds of livestock in the integrated farming systems. These models conserve the native breeds. By this way also our own resources which are being conserved, that productivity of these breeds are also enhanced due to the scientific planning of integrated farming systems by way of for round the year fodder, mineral mixture, and also the timely deworming, and also the other measures like artificial insemination. These breeds are conserved, their productivity is enhanced through the integrated farming systems. And we measured the emissions, greenhouse gas emissions from the all our IFS models, and most of our IFS models are either greenhouse gas emission neutral or they are negative. So negative means still there is the sink is more than the source. So that means we can enhance the economic activities from these models wherever the emissions are negative. Due to the presence of orchard, boundary plantation, agroforestry, and recycling units as an integral part of these models are these models are negative, emission negative. So these still scope offers the scope for the more intensification with the more economic activities. Still we can enhance the income from these models. And this is just to time is very short, so I would like to very briefly tell that in the northern region, these models helps to enhance the income of the farmers by 3.6 times over the income estimated by the Doubling Farmers Income Committee. And also in the eastern region, the income of the farmers can be enhanced by 4.9 times in a sustainable way. Whatever the income which we are showing here is, it is taking after taking care of the your sustainability in terms of soil, sustainability in terms of use of land, in terms of resources, other resources, and maintaining the ecological balances, provisional services, etc. Then in case of western region, there is a potential for 3.6 times improvement over the DFI estimated income of 2000 based on the 2015-16 prices, and in case of southern region it is 3.5 times improvement is possible, and state-wise details are also possible here. And apart from these models also ensures round the year income for the family, and across all the models, these models provides like rounds the year income to the farmers, so that they can manage their activities, social as well as the agricultural activities in a befitting way, without getting the loan from the others. So this type of things also happens, and this also helps for the self-employment and also the empowering of the women also, because these models, these type of integrated models which are carefully designed, helps for the share in terms of work. If you see, 48% of the work is shared by the men, while the 52% is work is shared by the women in this type of models. So this is a overall picture about the income enhancement and also the saving in terms of nitrogen, phosphorus, and potassium in the different agroecological regions. And we have also worked on the on-farm farmer participatory research in different locations, wherein with their low-cost interventions, like module-based low-cost interventions based on the farming system typology, which I have explained in the beginning. With the low-cost interventions, the income of the farmers can be very easily enhanced by the 2.7 times in 2 to 3 years. And we have measured the sustainable livelihood security index. That is, we used this particular parameter for measuring the sustainability of these our IFS models. And this sustainable livelihood security index encompasses of 3 aspects. One is the ecological security, which takes into takes care of the soil, land, all other related parameters, and the economic efficiency of these particular different components and the system as a whole, and also the social equity of the farm households. That means in terms of consumption of the diversity of the products like cereal, pulses, fruits, vegetables, and also the milk consumption, and also the expenditure pattern with the top the other households in the urban households and rural households. So these type of parameters and all these ecological, economic efficiency, and social equity index, all these 3 combines, and then the sustainable livelihood security index is made for the analysis of these farming systems. So for a successful integrated farming systems to be practiced, we need to maintain a diversity, which is very critical for the successful practice of the integrated farming system. Need to get into all these type of crops in a whole, like cereal, pulses, oil seeds, vegetables, fodder, millets, flowers, fruits, and also need to go for a recycling, which can enhance the biological nitrogen fixation. Because due to the diversity, the availability of marketable surplus will be very low in case of integrated farming systems. Therefore, the aggregation and value addition, small scale processing plays a very critical role in terms of successful organization or the practice of the organic farming, farming systems, integrated farming systems. And based on our on-farm research program, we have come out with a certain guidelines for development of a climate resilient villages through the integrated farming systems, wherein 6 modules are very critical. In each of the module, 4 critical interventions are suggested, which the inclusion of skill development and custom hiring can be an integral part of these models to make a climate smart IFS villages, and these are being also implemented through our on-farm research program in the integrated farming systems. And there are several schemes of India, government of India, and also at the state level to reap the benefits from the integrated farming systems. The several components can be converged together to get the benefits of extend the benefits of these schemes in a integral way, so that when we implement crop alone scheme or the livestock alone scheme, the output or the benefit to the farmer is in terms of only income, while we converge all these schemes into a wholesome package in the form of a integrated farming systems. This helps for the sustaining the natural resources, improving the productivity, enhancing the income, meeting the household demand, enhancing the nutrition, and all the national priorities can be addressed through this convergence of these schemes. This is some of the schemes of the Ministry of Agriculture, Animal Husbandry and Rural Development, which can be converged for creating the IFS clusters. And once we converge at the ground level, all these schemes, the benefits of the wholesome benefits of the integrated farming systems can be realized in a short term, maybe in a period of 2 to 3 years. Thank you very much.
Thank you, Dr. Ravi Shankara, sir. Any questions regarding the topic? So, by considering the time limits, any questions from participants? Is there no question? Then I proceed further. Dr. Ravi Shankara, sir, thank you so much for your nice and comprehensive resourceful talk on integrated farming system with respect to natural resource management, sir. You have discussed the prototype of IFS models, particularly Gujarat model, that is very consecutive. You have also narrated the 7 integrated farming system sustainable development goals that will really enlighten the participant minds. You also discussed how the integrated farming system that improve the soil health, how it improved the energy efficiency. That is really appreciable, sir. So overall, your topic is very much enlightened for participants, sir. Thank you so much for sharing the resourceful presentations and talks, sir.
Thank you, Dr. Patel.
Okay, thank you so much, sir. Now, without further delay, I invite Dr. Puneet Mehta, sir, for our next talk. However, by considering the time limits, I drop out one lecture of Dr. Neeraj Kumar, sir. It will schedule on next or for some other days. So this is our last presentation and talk. So kindly all the participants are requested to bear with us. And this is a rapid fire session, so only 10 to 15-minute talks are there. Now this platform is hand over to Dr. Puneet Mehta, sir.
Okay, thank you, Dr. Tushar Patel, for retaining me on this platform. And as I have been given a talk, particularly to talk about soil carbon sequestration. Is my voice audible, Dr. Tushar Patel?
You are audible, sir.
Okay, and my screen?
Your screen is still not visible. Kindly share properly.
Now?
Yes, it is visible now.
Okay. Okay, so a very good afternoon to one and all. And as I have been given
Dr. Puneet Mehta, please share your screen. Dr. Puneet Mehta. Hello, Dr. Puneet Mehta. Dr. Puneet Mehta. Hello, Dr. Puneet Mehta. Hello. Please be with us, dear participants. Dr. Puneet Mehta will soon connect with us. Hello, Dr. Puneet Mehta. Is there any problem with you? Dr. Mira. Hello, Dr. Puneet Mehta. Hello, Dr. Puneet Mehta. I think there is a problem of internet connection with Dr. Puneet Mehta. Please hold on, dear participants. Dear participants, today we have successfully completed the 3 lectures by the eminent speakers, Dr. Ajit Singh Nayan sir, Director of Research from GB Pantnagar University, Pantnagar, Uttarakhand, on role of geospatial technology in sustainable resource management, to combat climate change. Then after the second lecture was delivered by the Dr. C.R. That is C.R. Chinnamuthu sir. First lecture, that is Chinnamuthu sir, already given on the topic nanotechnology application in agriculture with special emphasis to natural resource management. As well as Dr. N. Ravishankar has also narrated the theme on role of integrated farming system in nature resource management. So as the title of this webinar, that is sustainable agriculture through natural resource management. So we have tried to cover each and every aspect that is related to the natural resource management, that is directly affected on the sustainable of agriculture. Dear participants, I want to share with you that in the series of this webinar, this is the national webinar, there is a series of lecture that is the which cover each and every aspect. Unfortunately, today the time is too much going on, and also our the other speakers are having a very or no poor low or poor connectivity of internet. So that's why Dr. Puneet Mehta is not able to connect with us. So we'll try to arrange this lecture, Dr. Puneet Mehta and Dr. Neeraj Kumar, tomorrow or day after tomorrow. So dear all the participants, so it is my immense pleasure that in this webinar, the participants from over the country as well as over the globe are participating over here. So I'm highly thankful to the participants who are coming from the all over the states of the India as well as over the globe. So please, today we are going to stop the first day technical session of this webinar, and we will arrange these two lectures of Dr. Neeraj Kumar on climate change and Dr. Puneet Mehta on soil carbon sequestration tomorrow or day after tomorrow as an availability of or the time. So definitely we will cover these two lectures in next session of the day. So today I am highly thankful to all the participants who join us in this technical session of first day. Dear participants, we'll meet tomorrow morning, right, 10 o'clock with the we are having a very good speaker, that is the Dr. Himanshu Pathak tomorrow, that is Director of Natural Institute of Abiotic Stress Management from Baramati. Then after Dr. N.K. Sharma sir, Principal Scientist from Dehradun ICR Institute. Then after Dr. Siddaramappa Gadenkari from the ICR Center from Dharwad, as well as Dr. Jaimin Pandya and Dr. H.M. Patel from Navsari Agriculture University. So on behalf of the organizing committee, I'm highly thankful to all the participants over here who participated in our inaugural session as well as today's technical session. So this session is over now, and we will meet tomorrow morning, right, 10 a.m. So I again thankful to all the participants from the country as well as from the overseas. Thank you. Thanks a lot.
Dear sir. Sir. Can we leave the session?
Yes, yeah. Now we can leave the session, okay? Because the two speakers, Dr. Puneet Mehta has a very low connectivity. That's why he is not able to connect with us. So we will arrange his lecture tomorrow or day after tomorrow as per the conveniency of our time. Okay, Dr. Alok Srivastav, please leave the session.
Okay.